Okay. This stream, I have a bit of a problem right now. And you might be able to see the problem right in front of you. Then this little problem is called salad. Okay. Okay. I've only got one arm. This is a really difficult, tricky situation. Yeah? Hey, salad. Yeah? Okay. Maybe a microphone goes there? I don't know. As you can see, I'm currently a little bit obstructed. So, I don't know when or how the coding will start, but you know. Is that a cat scratch? Yes, this is a cat scratch. Okay, salad. Yeah. Yeah, okay. Okay. Salad is a ragdoll cat. You know, salad, I kind of want to use my keyboard. Yeah, my keyboard, yeah. Salad. Yeah, this is not viable. Mister? I'm trying to stream. Yeah. Yeah, I'm trying to stream. What do you have to say for yourself, Salad? You want to talk to chat? Here you go. Talk to chat. Okay. I am also waiting until I can start doing the thing that I was supposed to do. Salad. Yeah, are you gonna sit there? You're gonna sit there all stream, buddy. Can we find a compromise solution? Yeah? What if you sit in my lap? Can we do that? Like if you sit in my lap, then you can still get cuddles and I can do my programming. Yeah. Then I can do my programming. Do my boring computer typey stuff. Yeah, you're in the way, buddy. He's just very cute. So like I feel bad if I force him away. But wait, are you pressing buttons, buddy? Don't press buttons. Yeah. Okay, Salad. How about my lap? Come on, buddy. Yeah, come on, Salad. Okay, maybe I can get you a hoodie string. Hoodie string. Yeah, you like the hoodie string. Yeah. He's so damn happy. Yeah, he's purring right now. Like listen to this man. Like he knows he's up to shenanigans right now. And I think that's why he's enjoying it. Okay, Mr. Limlom? Yeah? Can I scoot you into my lap? Can Can I scoot you into my lap? Okay, we're gonna make an attempt. We're gonna see if it's possible. Okay, you ready, Salad? Okay, come on, buddy. Yeah, come on. Oh my god, he's just increasing his mass as much as possible. Ugh. Okay, how about this? How about this? Yeah, I can get you a hoodie string. Hold on. He's boop, boop, boop. He likes my hoodie strings. Both Toast and Salad, when they were kittens, they used to like suckle on these little strings, and they still do it now that they're adults. It's really cute. But he doesn't like being in my lap anymore. He's an adult. He can't be in mom's lap. Yeah. His only purpose is to disrupt my keyboard as much as possible. Mm-hmm. Yeah, you're showing your butt to stream. Hey? Blip, 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 blip. Okay, so the Salad. The thing is, this is the only spot that you can't be at. Like, there are so many spots. On like this desk alone, there's a bunch of spots. But you're choosing the one spot where you're directly in the way. Yeah? You're super in the way right now. Like super duper in the way. Mm-hmm. Maximum attention spot? Yeah, it works, unfortunately. Like, this is the... He's figured it out. And I'm such a pushover. I give him exactly what he wants. Okay, Salad. I want to get some work done. Yeah, I want to get some work done. Yeah. Yeah, I want to get some work done. Oh, are you going somewhere? Yeah. Well, that's good. Where are you going, bud? You going to camera? This is the camera. Yeah. Nip, nip, nip. Oh. Okay. Thanks, buddy. Thanks. I can finally use my keyboard. Okay, Salad. Can I have my mouse? I need my... Salad? I need my mouse. No, don't step on the keyboard. No, no, no. I need my mouse. There we go. Oh my god. Okay. Yeah, buddy, I'm still gonna need my keyboard, so... Okay. Okay, Salad. He is heading... He's heading to the cat tree. Hey. What kind of keyboard do you have? I have the Mistel Air 1. Okay, buddy. Yeah. Keep those claws sharp. Yeah. Good job. Is today the day for poly traffic and flow? Traffic, I'm not sure. Maybe. Guess it depends. Depends. It depends on what we mean by traffic. Okay. So I have now set up this exclusive, extremely high-tech, multi-camera situation. Look at this. Got my usual camera, and then we've got the cat camera. So like, I can like toggle the cat camera on and off if there's a cat situation happening. Like getting cat hair in my mouth. Yeah, hello? Yeah? Well, you can sit on my lap. Yeah, come on then. Yeah, come on then. Hey. I was just ambiguously threatening to disrupt the stream. You want to make a choice, buddy? Yeah? Oh, okay. What are the other cats doing? Well, they are literally right up there in the same cat tree that Salad's sitting in. You can see the little fur tufts sticking out over there. Salad? You're gonna sit there? You're gonna sit there all stream? Yeah? Okay. Yeah, it looks kinda sad right now. Yeah, what are you sad, buddy? Or are you waiting to strike the moment I try to do something? Okay. No cuddles, okay. Okay. All right. Surprisingly quiet. Well, I mean, if they're asleep, they're usually quiet, unless they're snoring, so. Okay, let me just get my stuff ready. There we go. Okay. Cool. Cat snore, good or not good to know? Wait, the fact that cats can snore, or it is excellent to know because it's adorable. So if you haven't seen or heard a cat snore, it's very cute. Okay. Then I guess I'll open the project. Talon, hey, what's your plan? Do you have plans? Yeah. Do you have any plans? Where are you going? Where are you hanging out? He's just sitting there. Mister. Yeah. You look so disappointed. You look so disappointed, Talon. You look so disappointed. Yeah, okay. Yeah. You can sit in my lap, that's okay. What? Okay. He just tried to eat the shock mount, and then he did the You know that motion you do when you almost throw up, but you don't actually throw up? You just do the motion? There's a word for this. I forget. I was going to say convulsion, but that's a different thing, right? Other videos are really helpful. I'm really happy I like them. Gagging. Yes. Yeah, I think gagging is the word, right? Okay, there we go. Oh, wait. There we go. Gotta have the cat version of the camera. Compiler errors, that's okay. Where are you making half edge? It's in the FAQ below the stream. Wait, did I open safe mode? I don't want safe mode. Oh, it crashed. Okay. Oh, salad. Now you're dangerously close to my keyboard again. Mr. Man? Mister? No, that's a keyboard. Yeah, that's a keyboard. Yeah. But I'm making half edge because I want a 3D modeling tool that's made for game developers, and I want it myself. Like I used to do 3D modeling in Maya, but I no longer have a Maya license, and it's too expensive. And Blender is I didn't really like Blender, and so I figured I would try to make my own 3D modeling tool. And I was kind of curious to see like how far can I get? Like how close can I get to something useful? And so that's what kind of started this whole thing. Yeah, I don't know if that answered your question. I feel like I should do a bunch of code cleanup. Probably not the most entertaining stuff to do on stream, but maybe that's okay. Are you gonna upgrade to 6.3? Probably. I mean, unless there's something bad that's happened along the way, but usually for half edge I stay up to date. Oh yeah, okay. I was starting to set up like generalizing the coordinate relaxation stuff, because I wanted to make it so that it was easy to just have a function that can return relaxed coordinates and then just use them with arbitrary subdivisions. Because right now I do have the code for making the relaxed coordinates, but I don't have a generalized system for that, and I don't store that data anywhere, so I need to do that. Okay. I'm in the wrong scene. What kind of scene is this? Is there a... there we go. Not loving Blender is worrying. I mean, not the extent to which I don't like Blender is like very shallow, so don't read into that. Like, it's just, I didn't like the camera controls because it was different, which is, you know, that's not a real criticism. And I didn't like their UV editor, which is the one I tried a few months ago, which is different from the one they have now. I mean, there's probably going to be things that Blender does that I'm going to also do in half edge. So like I do like some of Blender's axis specific hotkeys, like being able to press X, Y, and Z to do axis movements. Like, I think that's a pretty good idea. I don't think that should be the main way to move stuff, but I think that should be accessible. Okay. I'm actually gonna go grab a headache med because I feel like a headache is about to come on, and I would like to not have a headache. So I'll be right back. Okay. So what are we doing today? That's probably a good thing to just sketch out so that I don't get lost. I have a tendency to lose track and get stuck in stuff and lose my way in my own head. I guess there's sort of a few different routes we can go. So last stream, we were kind of wrapping up the relaxation code to basically find nice coordinates within a tessellated triangle that will like try to equalize stuff like area, edge lengths, and internal angles. So I believe I still have that code. Maybe? No? What? Why did I do that? There we go. Not that one. Not that one. This one. Oh yeah, we also tried like projecting those onto the actual spline. That's what we did. Right, right. Was it this one? Maybe? Yeah, this is what we did last stream. Okay. So, yeah, so I have these controls to like optimize the mesh for different properties, which sometimes creates, you know, some art, which is cool. Yeah. So this was kind of the default distribution for the vertices, which is kind of like the naive, or not the naive one. The naive one is this one. But then I had a different version that I called projected, which by accident, this one actually has equal area for all the polygons, which was by accident, which is kind of cool. But it's not a very good pattern because it has these like really sharp turns and really distorted quads. And so the past few streams, we've been working on equalizing this stuff so that it can smooth out these various quirks. So like optimizing by angle will start smoothing out all of these, kind of like geodesics going across this thing. Yeah, so this is optimizing by angle, then we can optimize by area, and then also edge length. They all have different trade-offs. I think there was a particular low poly case that we were looking at. Probably this one, I think. But we did fix the... I think that was caused by a different thing, where like the internal triangle sort of had the wrong size. But I think it's different now. So I think now it's actually not too bad. It's looking kind of flat though. Is it supposed to be this flat? Oh wait, it's because, yeah, okay, hold on, that's my fault. It is because of this point. So we're gonna move that out. It's probably supposed to be somewhere here. There are at least some settings where all of the areas are colored, at least a some amount of red. Should that be expected or possible? Yes. It's because it's optimizing this in 2D, but then I'm visualizing it on the Bezier patch. And then it's using the area on the Bezier patch, but comparing it to the area on the 2D version. So the 2D version is more representative of like what we're actually optimizing. So yeah, so it will look a little bit different because of that. Oh, this one got wonky. There we go. Right. Okay. Okay. So I think I want to max out the area optimization. I really like the way that looks. Edge optimization, I didn't care much for at first. But then as soon as I looked at it in 3D, I realized that the edge optimization is actually really good to make it align with the tangents. So I think this is probably pretty good in terms of area. But then if we go to 3D, you can sort of think of like a edges going down, or one edge going straight down here, and an edge going straight left here, and an edge going straight right here. So this is the corner of a bevel, right? And so you would want these to be pretty aligned with that tangent. And I feel like it's not quite there. Like I feel like this one should point straight up, but it's pointing kind of to the left, right? But if I optimize my edge length, all of these kind of straighten out. In a way that was kind of hard to tell when I was just looking at the barycentric coordinates in 2D. So I think the edge length optimization is actually really useful here. Yeah, because this is kind of like a really, really bad case. Yeah, okay, calm down. Jeez. Stop exploding on me. Okay. To avoid vertex explosion, maybe clamp angles, but then I don't get art. I like the vertex explosions. Am I interested in advent of code? I haven't really been that interested in it now. I feel like I have enough puzzles to solve on my own. I'm not like lacking puzzles. So usually if I want to do problem solving or like interesting code puzzles, I can just keep on working on half edge because it's full of them. So, what's the reason you want areas to be close to the same size? It's just a general thing to want to have kind of like even like vertex density and face sizes. It's usually nice to have that in your meshes. Because then you kind of get equal levels of detail for every part of this. Because in an ideal world, you know, there wouldn't be any difference in shape anywhere. But because it's low poly, you kind of want to make sure that, you know, if you get some jagged corners, you get sort of the same jaggies everywhere, instead of making it look very jaggy at the corners and then it looks super smooth in the middle and then very jaggy in the corners. It's kind of better to have uniformity where things are equally jaggy everywhere so that it's not kind of like distracting by making like one part very detailed, but then the rest is low poly, right? I think it's possible to reduce the size of the corner cells while keeping the angles the way you want them and having all the divisions the same length. Yeah, no, the optimal, like optimizing all the angles and all the edge length and all of that to perfection is just not possible. So it's just a matter of like weighing the options and trying to figure out the best solution. Let's see. I feel like this one doesn't go up enough. Am I mean, I guess I haven't placed the control points in a perfect sphere, so it could just be that. Could just be my bad placement. Because ideally, the spline patch itself would go directly upwards here, which would be somewhere there. Actually, I guess I can use the ortho views to make it aligned. Because I believe centered on these two is the optimal, or is it in the corners? I forget. I think it's centered on here, from what I can remember. Oh wait, actually, I mean even the other control points, they're not they're not even correct. That would make sense. I'm stupid. I'm just being stupid. Where's 210? Is this one aligned? Eh, good enough. Okay. Anyway, I haven't placed the control points to be a perfect spherical sector anyway. So I guess, I don't know why I'm doing this. I'm just like trying to feel satisfied with this shape, I suppose. Where'd you get the cool hoodie? In a pop-up shop in Japan like 7 years ago or something. Just had it for a very long time. Does the trade-offs you pick here generalize to other bevels? To triangular bevels, yes. But I'm gonna have well, I mean, I'm guessing I'm gonna use the same weights regardless of which, regardless of like how many sides there are to the bevel, I think. Yeah. Okay, so there are a few things I could be working on next. So I just need to make sure that I wrap my head around what's up ahead. So one of them is to do to basically generalize to not just have triangles but also have quads and n-gons for the bevel. So that's one thing. Generalizing the number of sides. The other one is kind of related, but the other thing that I need to do is, given like this, solving this is a pure tessellation thing. But the other thing that I need to do is also to define the shape, like the actual, you know, the spline shape that I have for when you make a bevel. I need to figure out what should the spline look like for each of these patches. And these are kind of two entirely separate problems. The spline patch defines the actual ideal shape, and the tessellation defines the practical real-world tessellation that will happen on that shape. So the tessellation is kind of a separate thing from the shape itself. And yeah, there are a few things I've done so far for the bevels that are kind of hard-coded and wonky. So that there's some like refactoring that I should do to clean this up. And there's also another, it's also something that I broke that used to work. So it used to be that I had a bevel, you know, if you make a bevel where you select like the top two corners of a surface, kind of like this, I suppose. Or wait, there was no bevel after that. Okay, very good picture. I'm very good at drawing. So like this part right here, I broke this recently. So like defining this spline, I broke because I kind of hard-coded the triangle case in and then ignored whatever would happen in this case. This case is much simpler to solve. It's just that that code is broken now. So I would need to make that work again. I think it would be good to start setting up some kind of way to generalize the number of sides and bevels. Because now I haven't set it up in a very good way. Trying to figure out if I should like, because I've kind of solved this case now. This case is solved for triangles, all of these. And I'm trying to figure out, should I solve the quad case as its own separate thing? Or do I solve the n case of like any number of vertices? I feel like I should do the n case of just any number instead of just triangles, I think. Why did you switch to YouTube? I want to experiment. I want to see if YouTube makes more money than Twitch, because Twitch makes like zero money. Very, very little. But on YouTube, the videos the VODs will stay up for a longer time. And also, the VODs just get more views on YouTube than they do on Twitch. And on YouTube, they actually generate ad revenue, so that kind of incentivizes me to stream more often instead of not streaming, because it's kind of nice if I can make money from streaming instead of not making money from streaming. Is the quad case the only one where the middle isn't a triangle? It might actually be. Not entirely sure. I haven't thought through all of them. What's the reason you're coding your 3D modeling app? Does the current market lack something in utility, or was it just a fun project to pick? Yes. Well, yes to both. I mean, this is a fun project I'm doing because I do enjoy doing this kind of stuff. And yes, I would say the market does lack something like this. But I think, I don't know, I think this is a tough one to sell, and I don't know if the market would be able to like pick something up that's new like this, because people are very set in their ways when it comes to like, people who use Maya and Max, especially people at AAA studios, they are kind of bought into the whole pipeline. Newer developers and smaller developers tend to use Blender, and so it kind of looks like there's not really a market for something like this, but I sort of probably naively and very optimistically believe or hope that people like me exist who want something that is kind of like Procreate, but for 3D modeling. So that's sort of the goal. Okay. So I should solve the n case. How do I set up the iteration scheme for this? I'm working on half-edge meshes at work for non-art related stuff as well, so put me in the believer camp. I don't think it's going to be make or break based off of the underlying data model, but I'm glad you're a believer. Okay. Do we work on the relaxation infrastructure? Or do we work on the spline patches? Or do we work on generalizing the tessellation? I think those are kind of the three things. Did you see Proteus game editor? They did cool tech with UVs. I have not seen that. Is this the way that I'm going to solve for pentagons, actually? I guess. Probably tessellation is the most basic one, so you can visualize the results for n cases. Probably, yeah. Yeah, I think I should do that. The one thing that's kind of tricky with the n-dimensional cases is that I don't really have a nice way to represent, like, okay, so for triangles, or rather, okay, let's do an even simpler case before we get into the harder ones. So before triangles, in the early stages of planet Earth, there were line segments. So like getting a coordinate along a line segment is just a single number, right? You can just use usually for a lerp function, you would call it like a t-value, right? So you just have a t-value that's like from 0 to 1, and it's 0.5 in the middle, and that's the t-value. For squares, you have kind of two very natural axes. So that's usually where you would have your u-coordinate and the v-coordinate. So that's usually why it's called uv. So you have u-coordinates and v-coordinates that naturally parameterizes squares. But triangles are a little bit weird. In triangles, it's hard to find like a nice, natural, unbiased way to get coordinates. And so kind of the more common way to get coordinates in triangles is to use barycentric coordinates. So barycentric coordinates are kind of like, you have three numbers for, basically that tells you how close do you want to be to each vertex. And it's sort of based off of area. So for example, oh wait, I'm not on that layer. There we go. So if I'm color coding these based off of an ID or whatever, then barycentric coordinates are basically three numbers representing the area of these regions right here. Usually the total area is 1, so that the three barycentric coordinates add up to 1. So this is kind of like a triplet of coordinates. I don't know what you would call them. Like alpha, beta, gamma, or something. I don't even know what they look like. Is this beta? Like this weird little thing, except it should be green. Gamma? What does gamma look like? Is it this? Or is it the other way? Gamma is usually this weird shenanigan. You only need 2 coordinates then? Practically, yes, if you want to like calculate the last one. Okay, so this is barycentric coordinates, and barycentric coordinates are only well-defined for triangles. So like, okay, here we have a simple interpolation from 0 to 1. For triangles, we have barycentric coordinates, which are kind of messy, but they have a natural representation for triangles. For squares, we have u and v coordinates, so we have 2 axes. So like all of these cases have different ways of doing it, but then we need to generalize it to n sides. And now we get into the territory of generalized barycentric coordinates, and those are not, there's not one answer for what generalized barycentric coordinates should do. The problem is that like in barycentric coordinates, you kind of like every barycentric coordinate refers to a unique point. But if you want to do generalized barycentric coordinates, if you just say you sort of have the same system, you have a number for each vertex, and then you have like a convex combination. The problem is that there's multiple ways to represent any individual point. So a consequence of that is that transforming from like a regular world space coordinate to a barycentric coordinate kind of has multiple answers, and there's no like one canonical way to do it. At least not with the traditional like convex combination type of thing. So for n-gons we need patches. Well, that's kind of the question of like, do I want to use patches and barycentric coordinates, or do I want to do like, because I believe one of the, I don't even know if it's called like generalized barycentric coordinates, but I know that there's one approach, which is basically take a regular coordinate system and then just map your shape onto it, I suppose. With, you know, this would be 1, and then this would be 1 up here. And then you kind of have a 2D coordinate system in your shape. Kind of just like you have a 2D space and you have a you have your n-gon with a vertex radius of 1, and then in there you just have 2D coordinates for all the possible positions in there. Which is fine for just a very basic classification of a location. But it gets weird if we then want to use that for making spline patches, because we can't really fit stuff to that in a way that's kind of that's unbiased towards the choice of which vertex we're choosing as the root vertex here. Yeah, but I think if I'm specifically just solving the tessellation part, I think I can just use these types of coordinates to begin with, because that's kind of like, this is the coordinate system I'm working with for the unfolding stuff, for the shape optimization. So I'm doing this in 2D coordinates rather than barycentric coordinates, and I think that's just more generalizable. So I think I should start out with that at the very least. Yeah, so maybe that's the next goal then. To kind of like just generate those coordinates. It's just going to be tricky to translate those two splines, but I guess I could just use the, like, I could just take any n-gon, split them up like this, and then I can get the barycentric coordinate within a localized triangle sector. You could also define your points by the distance to 2 consecutive vertices. I suppose, can I do that? Well, that still wouldn't be unique, but I don't know if I would need it to be. But I guess the nice thing about this one is that it's unique, and that I already use this type of layout. But the harder problem for this, which is kind of like a silly problem, is more so the logistics of enumeration for all of these. Because I kind of hard-coded that for triangles, the way that I set it up right now. So I guess I would need to unhard code it. Where's my 2D case? Here we go. But yeah, I guess the next step would be to generalize this, to just have a, yeah, to just have another input to this function that's basically the number of sides. Yeah. Okay, is that what we're doing? Does that feel good? Are we on board? Ooh, okay. So, I guess we need to have a slider for the number of sides. Maybe side count, just to make sure it's clear. I'm not sure if I should be running the solver, because it's probably going to get mad at me as soon as I don't support. Actually, does the solver make assumptions about triangles? Oh yeah, I think it does. Yes, it does. Okay. Real test is going to be how it handles concave corners. Concave corners. Yeah, I know that generalized barycentric coordinates exist, but there's very little information on them, and there's no one standard that's nice. So I think I'm just gonna stick to my own. No, I have not looked at Blender's code. Okay. I think, so one thing that I do for my, one thing I do for my triangle stuff is that I use barycentric coordinates in general. But I guess I'm gonna have to ditch that. Yeah, I'm thinking about indexing right now. That's the thing I'm trying to work out in my head. Because I sort of have two different indexing schemes. I'm trying to figure out if I should drop the barycentric variant. It's just been really helpful. But I guess maybe I can do a different version of it. Where's my barycentric stuff? So this is what my coordinate system looked like before. So it's basically 4 integers. So it's a pseudo barycentric. It's not quite barycentric, or you can think of it as a barycentric in 4D. And this system has been useful in some ways, but it doesn't scale to n-gons, because then the data type would have to have more entries, and I'm definitely not going to use arrays here. So I think I'm probably going to have to go back to my older way of doing this. I guess this one is purely cyclical, or like spiraling inwards, but that's not super nice. I guess I can have a triplet of Yeah, I could have two integers for, like, what would it be? It would be, like, first which shell you want to be in. So that's going to be, like, S. So shell 0 would be the outermost one, shell 1 would be the inner one here, shell 2 would be this one, and shell 3 would be the vertex in the center. So that's one way to parameterize that. And then, yeah, I guess I could do, so then there's kind of a choice of like either I do shell and then index within that shell, just kind of like starting from here and going, like iterating through all the vertices here. Or I can subdivide it one more time to have like side and then quote unquote axis and then index. Or wait, or no, not side, sorry, shell, axis, index. So shell 0 would be outermost. Axis would pick which set of the 3 different vertices you want to use. And then index is how far into it do you want to be. So basically, I would be 0 at these 3 vertices if we're doing the x-axis or the red axis here, right? And then going to the next one would be 1. This one doesn't have a next. And then 2. Wait. There, 1, 2, 3, 4, 5. 2, 3, and then nothing there. So I did use this for a while, but it was really difficult to find a nice way to traverse the edge loops on this one. Maybe building the inner rings in order? I don't know. I think it mostly comes down to how easy or difficult it's going to be to traverse these arcs. Because that's kind of a mess right now. But I guess it's a matter of just coding that in, I suppose. Like, because when you're traversing along this arc, you're kind of switching between the 3 different sides here. But then there's also exceptions where if you're going through the center, it's kind of ambiguous which side this is, but it's clearly, I'm hard coding this one to be axis 0. But then if you go here, it goes directly from the x1 to the z1, unlike here, which it goes from x to y to z. And like all of these hard-coded things, they're gonna have to be generalized, but maybe that's okay. I guess it's not too bad. It would just be a matter of detecting when you would traverse to the next one. Yeah, I think the most important part, I think for me, is that I can represent a coordinate using 3 indices, or 3 integers. Because like generalizing barycentric coordinates to have n numbers of weights for all of these, that's going to be, that's not going to be viable, because then I can't use stuff like a dictionary to like map from a vertex to a coordinate or whatever. Yeah, so I do want to have a unique representation for this, specifically because it makes it easier to do dictionaries, because I make use of this a lot. Okay. Is there anything wrong with this idea? Is this bad somehow? There's also consideration for data locality where you want to keep spatially similar vertices closer in memory. I don't think that's going to matter for this. It seems like if you're using shells, you can only store points that lie along a given shell. And not ones in between, but if points are only ever generated on those shell lines, then that seems fine. Yeah, I mean, points will only ever be on the shells. It's kind of, the points are what defines those shells. So, yeah, the shells is purely a topological idea. It has nothing to do with actual coordinates. So now we're just looking at topology, not the coordinates. So this is purely just figuring out how to topologically traverse this whole thing. Part of me would be happy if something like a Hilbert curve was the right approach for this. I mean, a Hilbert curve is like, yeah, it would be space filling, but finding a space filling curve is not the problem. Because I could just index them directly from 0 to 36, which is what you're seeing here, right? Like, that would just be a flat array, kind of like a spiral shape. That would just go all the way around and then curve inwards here. Like this. So that's the straight indexing, just a spiral. And this works for all the different shapes. So, yeah. But of course, doing that is very inconvenient, because then I'm gonna end up in a practical situation of like, okay, I want to figure out how do I traverse these vertices along this path? Like, the figuring out which index this is, like these indices, given that they're stored in a spiral, is going to be a nightmare. Like, ideally, this shouldn't involve a search at all. I shouldn't have to iterate through all the things, right? And so that's where, like, alternate ways of representing them is a little bit more useful. Like the weird, like, barycentric-ish variant that I had made that a little bit easier to traverse those arcs. Well, you can kind of see the arcs that I've drawn here. So that's kind of like trying to figure out these this traversal here. Yeah. Okay. Wait, where did my stuff go? Here. Okay. So let's see. It's actually kind of interesting that, like, doing this with the quads is, like, really wasteful. It's kind of overly complex for the thing that I would be doing. Actually, what would it even look like? Hold on. Oh yeah, okay, right. So okay, let's just imagine a quad variant of this. So let's see, that would be kind of like this for the, I guess we got 4 colors now. Yeah, I can't have like the problem is that the coordinates, I can't have a data structure that has like, you know, number 1, and then, you know, and then the number here is the number of like sides in the polygon. Like this would be a generalized barycentric coordinate, but I can't make use of data structures like that because that's going to be really slow. So like the length or the size of this data type in bytes has to be compressed to make this more efficient. So like I could have a single integer to represent this whole shape, but that's gonna be too cumbersome to work with instead. And so I'm thinking maybe I'll use this coordinate system. But I am a little bit curious what this is gonna look like for a quad. So like this is basically, it scoops all the vertices until it hits the next one. Scoops is a technical term. Very advanced. Not a whole lot of people know what it means, but you can like flex it to make people think you're cool. Right, okay, so basically the first vertex will grab ownership all the way towards the center. So that would mean these belong to the first vertex. But the center one is a bit of an exception because that's kind of technically ambiguous. The same sort of goes for any of the center lines. So I guess this would be, yeah, I think this is the way it would be set up. I think that's how it would be set up, right? It's the same shape for all of these, I think. Yeah. Yeah. Center one is always going to be a weird edge case. At least when there is a center point, which there isn't always. The one thing that I just really don't like with this setup is that like traversing simple shapes like this is like unnecessarily complicated. But maybe that's okay, cause I'm kind of like, I am trying to generalize this to n-gons, and I'm gonna have to suffer some consequences from that. It just feels so wasteful to use like the most wonky like enumeration scheme for something that's extremely simple to like enumerate in the specific case of like the square, right? But I guess that's just, we just have to suffer through that. So then basically I'm gonna have to try to figure out like what are the conditions for switching to a different like a different side when traversing along these. Do you know beforehand what kind of traversals you'll have to do? Yes. So the traversals I will have to do is specifically like, you know, in this direction, for example. Basically wherever the edges go and it looks like the edges are flowing, I'm gonna have to traverse those. So for example, on this triangle, you know, traversing along this one, like this, is super, super helpful. But the trickiness kind of comes from all of the like center points and the edge cases of like when you switch from where you're in one cell to the other, which kind of has to be based off of, you know, which sector you're in. It's such a like off by one nightmare, but it's doable, I think. So it would be something like, okay, starting from here, if I want to go in a specific direction, I would need to check if I'm hitting the center line. So if we hit the center line and if we are on the center line and then we want to go to the next one, we need to know that we're supposed to switch to the different side. Yeah. Okay. I guess there could be cases where like I have multiple representations of every point, but then I like simplify it or something. But maybe that's wonky. Or does that work? Hold on. So I'm trying to think of like, because the way that this is set up right now with this type of coordinate, like you can have invalid coordinates, right? So what do? We did shell axis, which is kind of like primary sector, and then index. So, or no, that doesn't work because it's kind of like a, no, never mind. No, I thought about it more simply in my mind just because I'm looking at a simple case, but it's actually more complicated than that. Why need an enumerate in the right order? What if parallel processing? It's not gonna... That's not gonna matter here. Or I mean, parallel processing is not a problem with this. Could there be some benefit to starting iteration from the center vertex? No, I don't think that's good because the center vertex doesn't always exist. So like, this one doesn't have a center vertex. Yeah, the thing that I was thinking before was like, okay, so if one of the coordinates represents shell, I was like, oh, if you're on here, you can just decrease shell by 1 or increase by 1. And that means you're going to traverse to this point right here. Which like theoretically works, but the problem is that this traversal, by decreasing shell, it's going to take you there. But then if you decrease shell from here, it's going to take you here. So then you have to go to the next one in the shell. Then you go to the next one in the shell. And then you increase the shell to get here. And change the local indices as well. And I feel like dealing with the local indices is actually going to be the most annoying thing with this system, I think. Because that's going to change pretty dramatically. And I feel like I need a good system to like figure that out. Could use floating point instead of integer? I don't see how that would make anything of this easier. What shapes should the center faces be in the general n-gon case? So where are we? Here. it would sort of depend on the shape, I think, and the number of subdivisions. But here's two examples of the pentagon case. I feel like part of what makes this so tricky is that like it really diverges. Like it feels like when you're getting the next point along a specific direction, it feels very consistent and nice. But the problem is that it diverges in this weird way where like here it's all going in this direction, and here it's all going in this direction, and at the center it's like ambiguous which direction it should go in. So you sort of have two answers for where you should go from this one line here. And I feel like that this one thing makes defining coordinates for this so wonky. It would be much easier if there was no central vertex, because then you could sort of find a nice way to set this up. Yeah, it's sort of like rotations to some extent, but not always. It depends on like how close to the center it is. So this has to be independent of the actual distance to the closest point. Right now, or I guess it depends on what you mean by distance. Right now, we're just thinking about topological traversal. We're not measuring any distances here. But unless you mean topological distance. When you generate the point, what kind of traversal in the abstract sense do you make? Well, I guess there's... Let's see. Is this a good example? I don't think so. This is a better example. Yeah, okay. So if I were to generate this one, or the way that I do it now, the way that I iterate this when I generate the vertices, or the faces for this, is that I kind of traverse from the outer part here, and then I need to know the neighbors. So I fill in this face. This is kind of the first face that I fill in. And I'm going in like this direction to like fill in the next face. And then I stop at the center, I believe. Yes. So I do that. And then I go to the next one here. So it's 3, 4, 5. And then I repeat that for the other axes. So it would basically be the same enumeration scheme, but rotated. So then we get, 6, 7, 8, 9, 10, 11. And then lastly, this one. So that would be 12, 13, 14, 15, 16, 17, and then I special case the center to fill in the center, if there is a center. Are you using a K-map or Carnot map? I have no idea what that is. We're not doing anything spatial, so anyone talking about like rotations or curvature or distances, this is purely a topological thing we're thinking about right now. Feel free to fill in those with hatching too. Well, it's just kind of time consuming, and you sort of get the idea, right? I'm doing it sloppily. Here we go. Wow. I'm doing bad coloring here, but that's okay. It doesn't have to be perfect. We don't have to be perfect. I guess I never drew the special case in the middle. Okay, so then the question is, or no, because someone asks, how do I enumerate it when I generate this stuff? And I think that's a good point to start at, because my coordinate system should probably be based off of this traversal. Because that probably makes a lot more sense. Okay. Actually, that's probably much better. Center one should be yellow. You should be yellow. Got him. I feel like you could pre-compute some kind of transform matrix. Transform matrix? Like with like an integer transform matrix to go from index to index, or? Okay, so we're gonna have to deal with like boundary cases either way. But I do feel like having an iteration scheme that's actually really close to this is probably really good. I kind of want to try that. I'm gonna... Can I get a render? Or do I need to draw? Or actually, I guess I can just... Yeah, I can just steal this one again. Okay, we're gonna steal this drawing from the sucker that drew this. Non-math person here, because I'm gonna explain the use case. We're pretty deep, but I'm making Bevels for a 3D modeling tool. We're rounding corners from a very high level perspective. We're rounding corners. Okay. First, I'm gonna neutralize the colors here. Actually, let's do the whole thing. Okay, so if we have this new theoretical enumeration scheme, then I suppose, let's see, these would belong to the first sector, I think. Question is, how far does it go? Does it include these vertices or not? Because it would definitely include these. I guess I sort of leaned on making it include more. Well, all of them would have to have the same number of vertices at the very least. It's kind of an arbitrary choice. Yeah. All of this is an arbitrary choice. Oh yeah, the vertex. Yeah, vertices, it's very clear which vertices belong to who here. Because in this case, we have faces in the center, but we don't have vertices in the center. So the interesting question is like, how would you do this when there's a vertex in the center? Because we're not enumerating faces, we're enumerating vertices. So we are gonna steal some more art. What? No, stop. So let's grab that. Okay. Okay, so here, at the very least, these should belong there. These should be there. And these should be there. Okay, I guess the way that I did it before was that the x-axis, or like the index 0, kind of has priority. So that's the one that would grab the center. So then presumably, but I can't make it grab forward all the time, because then I'm going to get inconsistent behavior around this. So yeah, how would this work? I guess these would sort of have to be owned by that side. So it prioritizes ownership backwards. Kind of like this. Okay. And here the ownership is unambiguous for the vertices. Okay, I like this one a lot better than the last one. Then I guess the only remaining question is, how would this generalize to these cases? It would generalize just fine, I think. Okay, let's do... What? Really? Really? That's rude. What? What? Okay, merge those. I drew those in a separate layer. Oh yeah, this one is a bit of a weird edge case because I left this one sort of technically has an n-gon in the center, but I sort of just plopped in a vertex there. I think I think it's okay to sort of hard code the center, because that's going to be an exception no matter what way we do this. So that's okay, I think. There is not always a center vertex, so I can't really rely on center vertices. Do you have a mathematical formula to define these sections' colors? No, but the colors, I mean, it's not going to be a color at the end of the day. It's going to be an index. Or do you mean like the way that I categorize these? Yes, I think I have a consistent system for this. So yeah, this is actually the same number of subdivisions, but it's got one more edge. So it's going to look pretty much the same, except we have one more edge, or no, two more edges, not one more. Right. Prioritizes ownership backwards in the cycle. That's how it works. So then we get this. And then finally, there are no more colors. We're out of colors. It's over. This is a much better, this is a much better iteration scheme. Because now it's basically, yeah, the kind of traversal that I want to do on this is easier to implement. Not super easy because I still have to deal with like all of the literal edge cases everywhere, but okay. So now we sort of have a 2D coordinate system, right? Well, I can't really use X and Y, but I guess I'll use its own color with. So let's see, do we start at the vertex or? Yeah, probably. But yeah, we basically have a U coordinate and a V coordinate, or index rather. A U index, V index, and which vertex it's closest to, right? And so then we finally also just have an index. I guess I can't call it V for vertex because that's already taken here. It feels a little weird to have them in this direction though. Because like my enumeration scheme, or the way that I usually set this up is like, it goes in this direction, right? So I would kind of want increasing to be in this direction and in this direction. But having this be 0 feels really weird. So I don't think I can stick to that. So I think I'm just going to stick to this, I think. No, because like, because when I traverse this arc right here, I kind of have to like, I would increase V, but then I would have to decrease U. But it's kind of nice if I can just increase, 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 increase. Because it kind of maintains a consistent direction. Now I'm just bike shedding this, because this really doesn't matter that much. Okay. I think starting from the inner corner actually makes sense. It doesn't make sense if there is no inner corner. That's when it gets weird, I think. I mean, I guess I can, but like, if I'm indexing by the vertex, not having the vertex be 0 feels really awkward. And then you have this like awkward like off-center 0. Because like, it makes a lot of sense for this vertex to be 0, 0, right? I mean, I guess I could... the other way to solve this would be like, okay, this vertex would be -1, -1, 0. And then this would be -2, 0. Then I satisfy both both of my requirements. So that's basically just saying like, fuck it. U is in this direction. There we go. That's the U axis. I unironically kind of like that actually, because it does solve the problem. But it still feels weird to have the like basis vectors point away from the actual primitive. But that's okay. Interesting. Okay. Are we ready to are we ready to implement this? That's what I'm talking about with transformation matrices. Yeah, in the sense that like you're kind of, it's a bit of a modulo situation, and you can probably use transformation matrices for that. Okay. Trying to figure out if I should actually use my cursed solution and use negative indices. It feels really cursed. It would be nice to... Yeah, I think I'm gonna stick to it. It does feel really cursed. But this maintains the cyclical directions that I use everywhere. Yeah. I think I'm gonna go for this. I think that's it. Okay. So how do we want to arrange these? Do I UVI or IVU? I feel like probably IVU. Or no. I don't like that it's called I, because it makes it feel like a lower, like a smaller type of iteration, but it's kind of a big iteration. This is like selecting a category. I can see arguments are both. It really doesn't matter. I guess I'll just do IUV. Okay. So I do have an existing type for this for triangles, but it's going to be so different that I think it's easier to just make a new type for this and then eventually replace the triangle one. Because the triangle one is just different in so many ways. Okay, I think we're ready to just do this. Ooh. What do we call this one? n-gon topology. Test, I suppose. Scripting, C# scripts, n-gon topa test. Okay. What about M, since it's an n-gon? Guess that would sort of work. Your thumbnail looks like 3 penises. What does your penis look like? Jeez. You should probably go see your doctor if that's the case. Okay, n-gon. Wait, did it not compile? Oh, okay. Model behavior. No, wait. Immediate mode shape drawer. Execute always. Draw shapes. Wait, no. There we go. Draw shapes. Camera. There we go. Boilerplate done. Just gonna close those things over there. Okay, so now we need a type for this. Hardly counts as boilerplate. It's a small boilerplate, you know? What do we call this type? It's like, it's not n-gon. It's more like specifically a quadrangulated n-gon. Quad n-gon? Quad-gon? And it's also specifically only for the topological stuff, at least right now. Okay, well, quad n-gon. Or no. It really sounds like a quad, but it's not a quad. And it also might not be quads. Maybe quadish n-gon. That's it. That's the name. Quadish n-gon. Because it's kind of like quads, but not always, but mostly. It's trying to be mostly quads, so we have a quadish n-gon. Okay. What do we put in here? Do we have instances, or do we just pass stuff? I guess it depends on if we need to cache things. I think the previous one was an instance. We can just start with that, I suppose. But most of these methods are probably going to be static. So let's see. We need to be able to enumerate all of these in various ways. Lattice n-gon. Qui-gon. You know, I really like the way that this is set up because it really highlights the underlying strategy of like kind of having quads that you stretch and then tessellate. Like it's kind of neat that it's very directly, it's just directly indexed by that method. It's going to be much easier than this chaos, especially now that I don't use these to generate the coordinates, because now the coordinates are just separate anyway. Yeah. Okay, so what kind of functions do I want? I suppose there's a few... maybe I'll start out with... maybe I'll... like, starting out with something that I can use to debug is like, I pass it a coordinate, an IUV coordinate, and then I want to get a position out of it that represents where it would be in a regular n-gon, right? I think that would be a good start for this. So, so we would return a 2D coordinate. Maybe we can just make this static for now. See how far we can get making it static. Static. So what would we call it? Get, or this would be, we need a name for this type of coordinate. What's a good name for this triplet of integers? I called the previous one tetra because it was 4 coordinates and it was kind of like a tetrahedral barycentric coordinates. But for this, it's not really a tetra anymore. Yeah, what do you call it? Maybe I can just call it index and then locus, IJK, NMP. Skew chords, corner space. I don't know. I'm not feeling any of the names so far. But, okay, let's just call it index. Oh, but Unity's, I think Unity's int3 types cast from integer to int3. So it's possible I might use this incorrectly if I assume it's just a single int, when it might in reality be an int3. But maybe that's okay. So we want to do index to flat coordinate. That's what I called it last time. Index? Address? That's pretty good, actually. I like address. That's kind of like how regular home addresses work. You have like different hierarchies of like, oh, Sweden, that's a big chunk. And then we go to the next chunk of like Stockholm. And then you go to the next chunk of like this postcode. And then next chunk is like this street address. So address is actually pretty good. It's very analogous to this. Although it's sort of a combination of an address and then just a coordinate, but these are kind of designed to follow chords. Yeah, I just feel like coordinates are, in my mind, coordinates are not integer things. they're usually floatigers, so. Okay. So how would we do this? If we, let's see, if we parameterize this, I'm gonna steal some more art. So it would be kind of like this, I suppose. Oh wait, oh no. I'm having an existential crisis right now. Hold on. Shit. I guess maybe it's okay. Yeah, this is a winding order thing. Guess it doesn't super matter. But like, I really want this to be flipped. Like, oh, I can't flip it unless I'm holding Alt. Oh, and then Photoshop decided to let go. But you know, like I kind of want it to be like this, because that would follow the like index to 2D coordinate would be straightforward here, but the way that I do my triangulation is the other way around, because like the natural way to iterate or rotate here is in this direction, but for when I do stuff with faces in half edge, it's left-handed. So kind of have a conflict of rotation orders here. That should be fine. I mean, it's gonna be fine. It's just that I'm gonna have to take that into account in various places. Okay. So how do we do this then? So basically we have a root direction, which is, that's just based off of the first, actually, it's going to be better to just call this IUV, because then I remember the order. So I would just be the index here, then we get a root direction. Do we then, oh, you know what? Can I just, I mean, this would just be a straight up bilinear interpolation type of thing. Yeah. So as long as I know the directions to the neighbors, I can just do a bilinear interpolation. That's like super straightforward. The only thing that I don't really do here, the hard part is that I'm gonna have to like validate this later down the line, because like if I do the bilinear thing, I can just allow whatever coordinates you give this one and it'll return something okay for the most part, but I think we can do that later. Okay, well this is just a simple basis, so I can just set up a coordinate system and then our u and v axes, which according to this would be, I guess, pointing in this direction? No, in this direction. Oh god, am I gonna use this cursed system? And this direction. Okay, I'm gonna use X and Y here. Okay, and this would be U, and this would be V. Please flip the U axis. It would really make this a lot easier. It would make this nicer. Um, yeah, I might have gotten these flipped. Hold on. Okay. I'm not gonna do the cursed thing. You are correct. It's gonna be too messy. My mind is gonna get worked. Axes are not consistent? Yes, that's because I just talked about winding order and kind of in a position where there's no right answer and I'm gonna have to pick. I'm gonna have to deal with inconsistencies regardless. Okay, so I guess we have U and V. So then I guess this is 0. Fine. And then we have the index. Okay. Sure. So IUV, and then we need the how many sides there are in the polygon. So that's side count. And then we need the subdivisions, which is n, I believe. I usually call it n, so I'm gonna keep on doing that. Usually, I guess n would be the n in n-gon, so that's a little bit confusing. Maybe I should call it n subdivs, and then like n sides or something. Okay. Cool. Then we need. I guess we just grab the corners, right? We just grab these coordinates. And then it's just a simple bilinear situation. Although, okay, what happens if there's not a center line? That's the big question, actually. Okay, so let's say we're here. Well, I think this is more confusing than it should be just because I'm drawing them curved here. But I guess it's kind of the same regardless. Like they all point towards the center. It's just a difference in like what coordinate I sample it at, I think. So that's fine, I think. Yeah, I think that's fine. Okay. So do I... Okay. Seems straightforward enough. So we need some labels for these. We need the center, and then we got this one. What do we call this? Root, maybe? And this would be next, and this would be previous. Something like that. Center. This one's the easiest one. There we go. I calculated the center. I did it. Look at that. Roots. Okay. So that is just... wait, what would that be? Tau over n sides, I think, gives us the... Yeah, okay. This is like the angular delta between each point. So... which is a vector. So that would be... yeah, that would just be tau over n sides. Yeah, okay. Oh, you know what? This would actually be easier if this was a complex number now. One of those rare use cases for complex numbers. Do we go for it? Complex. Wow. We are in unit circle land. Okay. Now it feels awkward to not use complex numbers here. It feels really bad if I were to do multiple like trigonometry calls just to get the next ones, because I know that I can just multiply them to like transform them. But god damn it. But whatever. This like barely matters at all. Yeah, you know what? I'm just gonna do it the shitty way. I'm so sorry. So we have root, and angular delta, the burden of knowledge, exactly. Okay, so that's tau over number of sides, and the I in IUV, I suppose. Oh wait, that's x. Okay. Although now that I have this, multiplying this by ang delta would kind of, you know, do the thing. But actually, can I do like, or no, it's not gonna do it. Never mind. I guess I could just always, I guess I could just make a function like that. Is there any benefit to using trigs that are complex here? I mean, easier to read. That's about it. And like I need to do powers if I wanted to get rid of both of these trig calls, because then I would do just angular delta, and then I would do like flow to root equals angular delta to the power of IUV dot x, I believe. But this would have to be like an integer number of powers, right? And then next would be angular delta times, no wait, it would be root times angular delta, and then previous would be, would it be division actually? Would that be the inverse operation, or would I have to multiply by the inverse of ang delta? It's probably the same, right? I don't know if I ever do a lot of like complex number division. But But yeah, I would need to do trig for ang delta regardless. Like even if I were to use complex numbers, I would need the complex number would use trigonometry. So but I guess I could implement a type of thing like that. Do complex numbers have oh my god, I can't use the keyboard. Okay, why am I sitting in tablet mode? Because I'm not using the tablet. And delta dot y. So like, is there an integer power? Well, whatever. We're gonna do it the bad way. It's fine. Shouldn't it be plus and minus instead of times and divided? Not if it's a complex number, no. Okay, so we got next. Previous. Minus 1. Plus 1. I guess I could at least turn this into a variable, but... What? Everybody in chat's disappointed. You're all, like, sad now. Do I have to do it with complex numbers? But then, like, I don't know a good way to do integer powers, because it feels kind of, well, I guess I could just do a for loop, but that feels kind of wasteful. And that might actually have precision issues. If I have an n-gon with like 5,000 edges, what then, chat? What then? It might not work anymore. We might run into precision issues. Or no, wait. Yeah. Or no, wait. Is this correct? Hold on. No, this is not correct. There we go. I think that's the way to do it. There has to be a power function already. I mean, there is one, but it's a... it supports like double precision exponents, which is significantly more expensive to calculate than an integer exponent. Like an integer exponent is like stupidly simple. Okay. Is this correct? I think so. Okay. Okay, I think we did it. Are we happy now? I guess I could even start out with, wasn't there like a complex off from polar? Yeah. magnitude and phase. Magnitude, we're not using magnitude here. Yeah, cool. Now we have much less understandable code. This is like the most confusing code if you don't use complex numbers a lot. Okay. I didn't even like... Well, I want them in float 2 coordinates, so... please tell me I can just cast. This is definitely not going to exist as a cast, no. Wait, we need a extension method. Do I have extension methods for complex numbers? No, no, no. Okay. Gloat. Wow. Amazing function. Oh, right, this one has to be... God damn it. See how much more messy this code got now? Wait, what? What? Why is it? Oh. See, we're using double precision for these too. Dang. Are we even saving the cost in that case? Maybe using float trig might have been better than double complex. Okay, so now we made an over-engineered way to get the directions. Okay. So let's see. We got root, we got next, we got previous, although that's actually the next vertex, not the midpoint. What do we call these? Actually, do I want to keep the... Or no, yeah, okay. So this is like next vertex, I suppose. So we really want next, which is root plus next vertex over 2. And then we want the previous, which is root plus previous vertex over 2. So that should give us the center ones here, I think. And then we need to know how far do we go into the shape, which I guess is, let's see, if n is 5, it's just divided by 2, right? For the distances there. Actually, do we need to do a bilinear? Do we even need to do a bilinear interpolation, or can we just use this as a basis? Because if it's always perpendicular here, it should be equivalent to using them as a basis, right? I think. What does it look like here? Yeah, that should be the same, right? That actually makes it even easier. Okay. So then we got the U basis, which would be, what do we decide for U? U is going to be next. Okay. So that's next minus root. Then we got the V basis, which is previous minus root. And then we need to scale it. So now this is 1, but we want that distance to be, it would just be 2.5 here. Here would be 2. So we just multiply it, I think? We multiply it by the subdivision over 2, I believe. So subdivisions over 2. And then I believe we can just do return u basis times iuv dot y plus u basis, no, v basis times iuv dot z, I think. And that should give us the coordinate. I believe that's it. Okay, so let's try this out. So public int, no, int 3 iuv. Then we need the, what do we have? Number of sites and number of subdivisions. So we want some parameters for that. So okay. I guess subdivision could go down to 1 theoretically, but that might explode. So let's just put it at 2 minimum. Okay. And then I guess we want to, I guess just drawing the polygon itself would be good as a base, just so we can see anything. So for each maths points in circle, count n sides, dot pairs. There we go. True. Okay. Line, draw line. A, B. Right. Well, I don't. No. Come on, come on. There we go. What else? Oh, actual thickness. Should be, I don't know, 1 pixel? No, 2 pixels. They're thick boundaries. They're like the priority boundaries. And then, what? No. is sleeping right now in the cat tree. Okay. I believe this should just draw an n-gon. What? Oh, n-gon topology test. There we go. Look at that. Okay. Number of sides. Wow. Absolute magic. We can make a pentagon. Okay, and then we got the subdivisions and then IUV. All right. So, okay, I'm gonna just use the same colors I used there. Get Vertex color or something? I don't know. I don't know how many colors we're gonna have. How many did I have here? I had 5? Yeah. Return, I switch, right. Yeah. Okay. So how do I do this? If I just want to start out by drawing the vertices, like iterating through those. So there's a bit of a weird exception with the center. So that's going to have to be hard-coded in. But apart from the center, I guess it's like, if it's odd, then it's very simple. They're always just, let's see, number of subdivisions over to round it down and then +1 for the number of vertices on each axis. But then if it's even, then we have 1 less on the u-axis. So I guess we should have, actually first a for loop for each vertex. So let's call that IV. And that would be n sides. Okay, for each vertex, and then we want to iterate through. Okay, the number of v coordinates is always subdivision over 2 plus 1. Yeah. I think so. And that was was it U or V? V. Yeah. V count is subdivisions over 2 plus 1. And then U count. So that's V count if the subdivision is odd. Okay, so if n subdivisions so if it's even, then it would be V count minus 1. Otherwise, V count, I believe. Okay, so then we have the index for, oh no, I can't use the same. What did I call it in the other? IUV, right, it was called I for this one. Okay, you know what? This one is I now. There we go. I guess that's independent of the iteration. Okay, so now we can do V count and then another one for IU. IV, IU. Okay, and then we call our function. Right? Yeah. Which was quadish n-gon. It really does vibe similar to like Qui-Gon Jinn. This is confusing me. Wait, that's not an instance type. Index to flat. And then what did I call it? I called it something different here. No, I didn't. Okay, n sides. N sides and subdivisions and IUV. Then draw dot disk. Oh yeah. Okay, then we need to set the radius space. It's gonna be pixels, and we want the radius to be 8. Why not write it in Rust? Because I don't want to write it in Rust. I want to write it in C#. Why is this complaining? Why is this sad? Oh, because we have like a test coordinate here. Okay, I'm just gonna comment that out. Okay, writer, why do you show a little box around IV? Why do you get stuck showing little boxes? I'm pressing escape. I haven't searched for anything. I've formatted the code. Can I just get rid of these boxes, please? Hello? Hello? Okay, there we go. I just have to remove the whole code and then like paste it back in. Makes sense. Why? Why? Why are the sticky boxes? Rust wouldn't have complained though. Your Rust never has sticky boxes in their code. Well, We have something for sure. We do not have the colors though, so we wanna set the color. So that would be in here, I believe. What color do we use? It was the, I called it something like get color, get vertex color. Okay. Did I... Oh, this should be divided? Yes, it should be divided. That's why. Pretty sure that's why. Strong attempt was made energy here. Okay, so there's one thing I need to do for the center vertex, because I never did that edge case. I guess I can just leave it like this as long as I can see what's going on. Oh, wait. I just did the local transformation here, but I forgot to add the root. Oh wait, plus. This feels worse. This makes me less hopeful. Why is the blue so overwhelming? Why is the blue taking over so much? Can the blue one chill? Oh yeah, I do need to do a bilinear interpolation. Yeah, I can't just use it as a basis. Okay. Okay. I think that's one thing that I know that I'm doing wrong here now. Okay. Why do you have to do bilinear? Because if I just add a basis, it's always going to be a parallelogram, but it's not going to be able to stretch it to a kite. But if I do a bilinear thing, it would stretch it to a kite. Is what I'm thinking. So, okay, I need to go back to this one. So I guess then I would interpolate between next and the center and root and the previous. And then I would sample along that, I suppose. Okay, so then this is not the strategy. We're not We're not doing this one. Okay, so we would do u, yeah, we would do like u start and u end, and then, yeah, okay, well, let's just start with that. So do I need a normalized u? I think so. I think that's going to make things easier. So that would be dividing by this number. Half subdivisions. Okay. Where's... Oh no, wait, that's iuv.y. That's z, that's v, normalized. Okay. Then we do a bilinear situation. Okay, so first we use the v coordinate. So that would be a lerp from root to previous with v normalized. Then do the same thing for the end, which is next to center. Next to center, based off of v normalized. And then we return rityub. I hope that doesn't mean it. Maybe I said like an Eastern European slur there, but math dot lerp from u start, u end, and then u normalized. Wow. Bilinear variant. And this was the basis variant. Okay. Come on. Let me see some coordinates. That looks perfect. I think this is correct, right? Let's see. Yeah, we're skipping the center vertex. Right, so this is an odd number of subdivisions, which means there's no center. If I change it to 6, now there should be a center, but we're kind of skipping it, which is okay. Okay, the weirdest thing is that this one is red. Why is this one red? I feel like this one should be red. Did I one index my colors? No. I'm starting from 0. So why is it drawing it up there? What did I set for my roots? Oh, wait. Is it maybe my int pow function where if you pass in 0, I think that's the problem, right? If you pass in 0 for the exponent. No, wait. Yeah, if you pass in 0, it should just return 1, right? Hell yeah, implicit cast, it did it. Good job, C-sharp's base library. But then should that really cause an off by 1 issue? I guess the answer is no. Wait, okay, yeah, I got this wrong too. Because like the number of times you need to multiply this thing is not the exponent itself, it's the exponent minus 1. So this is also off by 1. So this needs to be 1. Yeah, okay. Cool. This makes sense. I get it. I'm understanding it. And so this is making sense to me. All right. Number of sides. This is looking good. Oh yeah, I guess this one, it repeated the color, which is not, it's kind of confusing. Okay. You know what? Let's add some more colors. 5, 6. What other colors exist? I guess we have pink. Do you have any other? I guess my brand colors, I haven't used those. Orange. Okay, I feel like orange should be there just to make it look a little bit more interjected. Okay, so we have 7 now. I could do interpolation across the hue circle. Neat. Look at that. I could also make the slider max out at 7, and that way it's always gonna look all right. There we go. It will never break now. It's just perfect. Cool. Neat. Whew. This was a whole thing. I guess the next thing would be testing the iteration by actually iterating through these and like traversing it the way I would if I were to construct a mesh. So basically drawing lines. Gotta get the center vertex working. I suppose. I mean, it's going to be hard coded no matter what I do. I guess it depends on, like, am I ever going to have to traverse through the center? Well, yeah, kinda. Yeah, I need to be able to retrieve it at the very least. The points near the edges look weird, being far from it. Near the edges? Oh, you mean like the distance here looks like they're stretching away from it, or... But that's okay. We are mostly focusing on the topological stuff now. So the unfolding stuff that I did with the triangle, wherever that went, this one, like unfolding this shape, we're gonna basically have to do the same thing for the generalized case, because this was just triangles, right? But we're gonna do the same type of unfolding for n-gons as well. Okay. Oh, making the corner groups one index would be really cursed. No. Definitely not. Actually, what is the right answer here? Because this is an even... No, wait, this is odd. Hold on. Okay. So for triangle, we have a triangle in the middle. For a quad, we just have a quad in the middle. For a pentagon, kind of has to be a bunch of triangles in there. Actually, wait, hold on. It depends on subdivisions. So when subdivisions are even, there should be one there. But how does that work during traversal? It's hard to think of this center vertex in any other way than just an exception. Like it's always going to be a weird exception tacked on top. So how does this relate to, like, is it just based on subdivisions? Yeah, this one would also, so it's not dependent on the number of sides. It's just even subdivisions have a center vertex. Odd ones are nice and play well, and anything that's even requires a center vertex. Okay. I think maybe we can just pretend the center vertex doesn't exist for now. And then we'll deal with it later. But we can draw it at the very least so that it looks like I have code for this. So if, I guess we'll do a variable is even subdivs, or just even subdivs is fine. So if it's even subdivs, we draw a disk at 0. Oh, in white, I suppose. What? There we go. Look at that. Now it looks like we have proper code here. Neat. I'm just like enumerating this in my head to try and figure out how I would do this for the face filling. How are the fillets going? Wait, fillets? Fillets? I don't know how to pronounce it. Very slowly, because I'm sort of getting sidetracked. Not really sidetracked, but I'm over engineering some. I want to work out nice tessellations for n-gon cases when you have corners of a bevel, and so I did the triangle case like separately, but I'm now gonna try to generalize it to n-gons. So n-gons with any number of subdivisions. Yeah. So that's what I've been looking at today. So I guess we should do the edge traversal stuff, which is mostly straightforward, except for the boundaries. How do I want to parameterize this? Salad is snoring. I don't know if you can see Salad over there. That's my son, who's right there in the cat bed. He's snoring. Do odd number of sides with odd subdivisions not also need a center point? No? So this is odd. 3 sides, 5 subdivisions. No center point. Wait, odd sides, odd subdivisions, but 5 or greater sides? Oh, like the center point here? Yes. But that's like a special case, I feel like. Like that's gonna have to be, because that doesn't feel part of this type that we're doing now. Because like that center point has to be done in a separate step in like, yeah, because it's not really part of this topology here. But yes, you are right. That is true. Because like it's like special cases all the way. So like for the triangle, we just put a triangle there. For the quad, we put a quad there. for the pentagon, we kind of need to subdivide this into triangles. But then for the hexagon, we can subdivide this into quads. So like, but then when we go to the heptagon, we can't do quads anymore unless we want to do like 2 quads and, or no, 3 quads and a triangle. Or do we do just triangles? Like, oh God. Like any like prime number of subdivisions is going to be a nightmare to try and use quads for. So I guess it's just always going to be triangles for those. But luckily, like having a junction with more than like 6 edges is really rare. So it doesn't matter that much to make that case good, I think. Does the middle gap keep increasing forever? Maybe. It's possible. Why not triangle fan? I mean, you could do a triangle fan, but it's nicer to have quads. Quads are nice. So if there is a consistent way to have quads, it's usually preferred. Okay. So how do I do traversal here? I guess I don't super need to have traversal across the boundaries. Or no, I do need it across the boundaries, but I don't super need to have a method that like gets all of these in a row. I could just do these. Kind of feels like we're moving the tessellation problem to a smaller scale but still having it. What do you mean? This seems way better to me. It's mostly like a like if I were to index faces here, okay, maybe I'll do the oh, you mean the center thing? Oh, right, yeah. Yeah, it's sort of like recursively. I need a tessellation on a smaller scale, yeah. That is true. How would I want to traverse this? I mean, I guess there's a naive or like a simple thing. I could just like copy this. Let's see. So here we're drawing vertices, but then I want to draw edges. I guess for edges, we already have the outer boundary, so I guess we don't super have to draw that. But then again, if we do this correctly, we shouldn't need an outer boundary. And we're gonna have to do like -1 for some of these, or both of them. Okay, so we've got the root itself. Let's call this C. And then we've got the one along U, I suppose. So we just one step in that direction. And then we have one along V. And then one opposite. So those are kind of that would be the quad, right? Well, I guess now I'm traversing quads rather than traversing edges, but maybe that's okay. So let's say we then want to draw something inside of that. Face center equals all of these added together divided by 4. Wow. Oh, okay. So now it's not going to deal with the boundaries. It's just going to draw dots at the face centers, I think. I hope. Yes. This immediately looks very confusing. So we can't do discs there. This is super confusing. Okay, draw quad. We're drawing quads instead. So I guess we should make them pretty transparent in that case with alpha 0.3. Okay. C, CU, C opposite, and then CV. And these have to be float 3, I suppose. We don't need the center anymore. Oh, I'm so tired of all of these conversions not working out. New float 3, 0. God damn it. Wrong key. There we go. Okay. Look at that. Look at that. So what is the rule here? If I change to an odd number, then it's going across, right? Okay. Alternate universe Chrome logo, yeah. You get the Microsoft logo. I think this is like some kind of Nazi Microsoft, I think. We're like very close to a Nazi symbol here. We gotta be careful. Okay. So I feel like in this case, it can go one more step. Like retrieving the coordinates here is going to work. That's good. That's not going to be a problem. But the thing I will need to do eventually is that all of these coordinates need a unique identifier. And so I need to be able to grab a coordinate from that identifier, or not just a coordinate, but a specific identifier, I suppose. Or rather, I need to know the identifier of the neighbor and not just get there through coordinates. Which is what I'm going up against here. So like here I'm basically accessing the faces. I'm doing everything I can do without having to deal with boundary issues, I suppose. So this is just all the internal faces. It is dangerous to work in fourfold rotational symmetry, that's true. Okay. Okay. So then the question is, how do I want to set this up? I almost feel like there should be a function where yeah, it should probably be like a get quad function that's like boundary aware. So if I do a get quad function from this vertex, I'll literally just do an edge case of like if the U coordinate is here, then the next pair of vertices is going to be different. And the get quad function should not return coordinates. It should return the, I forget what we called it, the address. Yeah, that's what it should do. Okay, I think I've calibrated my brain now. So, okay, I feel like this really should be an instance type, because if we're doing a lot of like coordinate stuff, then like calculating this every single time we want to convert a single coordinate is wasteful and dumb. So we're gonna make this into an instance type. And these are just static methods. Which means, I suppose, these should be fields. And we need some kind of constructor for those. And, oh, is it sad because it might not be initialized? What? What? Oh, because it's static. That's why. All right, so I guess the angular delta is also something we should have here. When the app's going to be finished, can I drag and drop stuff, or am I going to be required to do math with for loops and stuff? It's made for artists, so it's going to be impossible to do for loops in half-edge. Half-edge is not a, like, it's not a procedural thing like geometry nodes or anything like that. It's specifically for for manual labor, the handcrafted artisanal art. It is not for machine art. So I have streamed for more than 2 hours, probably. Yeah, I've streamed for 3 hours. Yeah, I probably shouldn't stream that much longer. Right, so now we need to make a quadish n-gon instance. I called it cutie before because it was like a quadrangulated triangle, but qn doesn't sound as fun. Okay, n-sides, subdivs. Okay. Oh. So we don't need to pass both into it. If half-edge allowed code, Unity would bonk Freya. I don't think so. I think I'd be safe. Favorite root vegetable is a quadish. Yeah, Unity's TOS violation stuff is mostly like if you're creating a game engine. But like you're allowed to create games where you write code in the games as long as it's not a game engine, I think. Oh shit, thank you so much for the dono, Tamkish. Probably not going to stick around since I'm playing Blueprints, but notice your streams have some of my coins. Thank you for some of your coins. I appreciate it. Unity can't just trademark code. Unity can't trademark code, but what Unity is allowed to do is that they can tell you that like, you're allowed to use Unity, but if you use Unity to do this thing, we're not going to let you use Unity. Like, that's something they can do. So that's like, that's in their TOS, right? Asked about an hour back, do you try using AI for building things? Nope, I do not. I am not a fan of AI, so I do not like it at all. I think the closest thing I've done with AI is like, either I'm looking something up that I already know so that I can verify the answer. Like I forgot a word for something and then I use ChatGPT to try and like remember the word. Or I'm asking for references to papers that I should read, or like terminology that I might want to know. Like, I don't know, like if I need a keyword to search for, to find the stuff that I'm looking for, I can ask it to give me the terminology people use within a given field, like that kind of stuff. But I don't use AI for anything else. I've tried using it for code and it was a miserable experience and I will never do it again. Okay, let's see. What did I do? I refactored it. I refactored it and it's still working, so that's good. That's a good result. Using it like an assistant to bring out your idea to get implemented and checked in your code or 3D modeling? No, I don't. Why would I do that? Like, I don't have any reason to do that. Okay, so yeah, right, okay, I was gonna do the quad function. That's why I was generalizing this. Okay, now I'm back on track. So I need to make a function to get a quad in address form. So get quad, I suppose. Actually, it's gonna be, I guess we're gonna name them by address or something. Like that, I think. And then I guess we can just pass an address for that too. Like it's an int3 address for the quad address. It's kind of the same coordinate system. Okay. So theoretically, this would be very easy, but we need to do the boundary cases. I should probably range check in here actually to kind of prevent me from iterating this incorrectly. Yeah. So here I would it's always just +1 on the u-axis, right? Pretty much. Okay. So if there is an even number of subdivisions, the max for u and v, or the count, is always 2. If it's odd, it's 2 for v, but 3 for u. Okay, basically the same thing we had here. Let's see, we did on 6, it would be 6 divided by 2 is 3. And if it's even, wait, hold on. If it's even, they're both just divided by 2. Hold on. So I think the +1 is probably not applicable here. If it's odd, so this would be 5/2. So then v count would be 2. Right, it's like if it's odd, we need to do +1 for the u count. Yeah, okay, that makes sense. Is there a plan to visualize the UV decay unfolding in a 3D viewport? Which part? The one that I'm doing here for like experimenting with this, or do you mean like in half-edge itself, like in the finished application, or? in the finished application, yes, for like UV unfolding and UV relaxation, yes, there's absolutely going to be interactive unfolding. Interactive unfolding is like my favorite part of UV mapping, so I'm absolutely going to implement that. That was like the whole thing. That was like the whole thing that made UV mapping fun. And like, how can you not have that in every UV editor ever? Okay. Okay. I'm just gonna range check this, I suppose. So if U phase is less than 0 or U phase is greater than or equal to U count, throw new index out of range. Wow, I'm very good at typing. Okay, and then basically the same thing for the V coordinate. Cool. So then, all we have to do yeah, okay. So the naive version of this is basically doing this, I believe. Except without the fluff. I guess I should match the names here. I've often converted UVs to 3D to use normal tools. So I know that, like, is it 3D Max, 3ds Max, that has the UVW thing in their UV editor? I haven't used Max, so I'm not sure how that works. But yeah, how do they do that there? 3D Max has UVW and you can just pick the order, or like, how do you use the third coordinate? Like, is it ever used for anything? Because there's kind of like two different things I have in my mind when it comes to a UV editor that has more than 2 coordinates. So one of them is W being the, like, a rational weight, or W being just another coordinate, like just another number. But then I feel like it should be 4-dimensional, because like, why would you not add another dimension and just, I don't know. There are 3D textures? Yeah, that's true. Okay. Am I doing this correctly? 3D Max use it for 3D textures, but how do you set the W coordinate? Is it like you pick the axes in the 2D viewport? So you're like, oh, I want to see the U and W axes. Is that how it works? Right, okay. Okay. So I think this would be a little bit different now. Because now I want to use get quad, and that should unpack into those. I pass the, this is the quad IUV. And then from there, guess I would just be directly running these. Huh? And then we don't have to do these. And then quad v0 to v01 to v11 to v10. I guess. At least this is how it's supposed to work in theory. And I think these would just be like cached instead of like converting them. So basically this would now give you the address of each of those vertices. And then down the line, the actual vertex positions, they're stored separately, and then the address is used for lookup. But I haven't done the boundary condition yet, so I'm gonna compile just to make sure that nothing's broken. We should see no changes, ideally. Okay, this seems to work. This seems perfectly fine. Cool. Okay, so now the spicy thing. Now we need to deal with the boundary condition. So basically, we are gonna let you increase U by 1. So that would basically be checking if quad address dot, or no wait, it would be just if U face is what, actually? If it's the last U, that's it, right? If U face is U count minus 1, then we are on the boundary. Boundary to the next face, or next corner vertex. So how would that change the index? So basically we are getting four points, and we are getting these two now, but then we need to convert the coordinates we have here to the next one. So would we, let's see. I guess we would just swap u and v. Let's see, so this one would be offset over here. Then if we go to the next, it would be these two. But if we swap u and v, we mirror it back down here. Is that it, actually? Because that would be convenient. Let's see, this is u, right, okay. Yeah, it's these two that need to be different in that case. So if we're in the boundary to the next corner vertex, we take these two, or no, we just set them based off of the other ones. Wait, no, hold on. That might actually depend on if it's even or odd, because this one is different. Yeah, if it's even, we do one thing, but if it's odd, we do a different thing. So if it's even, we just do the swapping, I think. So then basically we would do A10 equals let's see, new int3 A00, I believe, yeah, dot z and A00 dot y, and then A00 dot, or no wait, I got these, x should be A00 dot x plus 1 modulo modulo n sides, I believe. And then the same thing for this one. But this should be based off of A01 instead. Okay. So that's the even case. If it's odd, then no, wait, hold on. Wait, did I get this reversed? Because I think if it's odd, this is correct. Yeah, I got this flipped. Or no, wait, this is even. If it's even, we take yeah, no, hold on. If it's even, I think I use itself. But if it's odd, I use the... Yeah, okay. I think that's correct. This truly is off by index hell. Okay. Do you have any deadline in mind for the release of Half Edge? Well, I really want to get it done next year. That's why I want to release 1.0 next year. But we'll see how it goes. Okay. If it's odd, we need an extra iteration for u. That's what we got here. So u count. Or no, wait, if it's even, yeah, we just need an extra in general for u count. So I think we just remove the -1 there. Okay. Come on, please just work. Please just do the thing. God damn it. It's over. It's over. Phase V index is invalid. V index of 2. Oh wait, U and V are mixed up here. Come on, come on. Hell yeah, hell yeah, look at that. It is working. Oh my god. Neat. Cool, we got it. We got it. We got through index hell. Because, good lord. Oh, okay. I just need to take a breather. There are too many indices in my head right now. I don't like how you can't like distinguish the different phases. You can't tell that they're like individual phases. I feel like we should fix that. Generating new Google products, yeah. What? Did it include the wrong random? Unity engine. There we go. We added some jitter to the opacity, so now it's gonna just like flash and be incredibly a lot. There we go. Wait, why is it darker towards the center? Did I bias it somehow? Oh, no, I know why. That's funny. I appreciate that. That was kind of by accident, but neat. If I just move this in here, it's gonna be consistent. There we go. No, it's just like vaguely flickering. It kind of looks like we've got Z fighting here. Why is it jittering? Because I told it to. But I suppose I could do some kind of even odd coloring or something. If IU times IV, if that modulo 0, or no, modulo 2 is 0, I suppose? Is that a valid condition for that? Oh, right. Should be IU plus UV? Yeah, this one does a different thing. I always forget operator precedence for modulo. Neat. This almost starts to look like the some kind of like UV map, like a test UV map or something. It's such a relief to have this working. I'm really glad this was a pretty straightforward process. Anytime I have to deal with all of these like index modulo shenanigans, I always get a little anxious because like there's so many indices and so many things you can mix up, so much that can go wrong. Wait, is this correct? Was it supposed to connect to the center? Oh yeah, it was supposed to. But the coordinate that it's grabbing there is not unique, I think. So that one is actually generating a unique coordinate for each side there. And that's not good. Do you use shapes? Yes, I'm using my vector graphics plugin to do all of this. So I suppose what would I do in this case? It's like if it's if the subdivision count is even, I guess I never thought that it could. I guess it would make quads that look really stretched, but sure. Like this like flower shape in the middle is kind of interesting. So I guess basically anytime if it's even and U and V are at the maximum, which would be subdivisions over 2, I think. Yeah. Then it should always return the one for the x-axis. I think that's how it should work. So where's our thing here? What do you use for UI for half edge? I'm using just Unity's UI toolkit for half edge. If you're talking about like half edge itself, like this interface here on the left, and the all the panels and whatnot, like all of this stuff is UI toolkit. So Unity's new UI system, new? Is it even new anymore? I don't know. But then everything that's like in the viewport itself, that's not using UI toolkit because that's all 3D. But yeah, so like drawing all of these lines and the gizmos and whatnot, that's not UI toolkit. But the interface is everything around the viewport and the stuff that's overlapping the viewport. Okay, Bevel, go. Look at that, still working. It's not, we didn't break it by accident. I'm really glad this is actually working. Look at that bevel. Okay, right, I was gonna do index cleanup. I guess I'll just make a function for that. Is it a verify index, or is it like a clamp index, or is it both, or I don't know. Or do I just hard code it to be in here? Oh, actually, you know what? Weren't you going to handle the center vertex in the even and subdiv case? Wait. Do you mean subdiv or like the number of sides? Because like wait, I'm not sure which one you're referring to. You're running custom bevel features as parameters to control the smoothness of the bevel. I'm just making any bevel that works right now. I mean, ideally it's supposed to be smooth, but I don't really have a smoothness slider. You need special index handling anytime sides plus subdivisions. Like if those are even? Oh, center handling. So like, I mean, it's anytime subdivisions are odd. I need special handling there. But if subdivisions are even, then the center vertex makes sense. So it all comes down to the subdivision count, I think. But I do need to fix the center index there. So even subdivisions, that's it. Okay. I guess I'll make a function that's like a new address here. And then what did I have here? It was that this is the I for a vertex, I suppose. And then we have U and V. This should be vertex, or no, I'll just do new address. I'm trying to figure out if I should do this thing inside of new address instead. Because then I kind of catch the same error there for all of them. Maybe it doesn't matter that much. Okay, what was I gonna do? It was gonna be if there's an even number of subdivisions, that would be this. There's an even number of subdivisions, and if the u and v coordinates are, let's see, 0, 1, 2, 3, so that's subdivs over 2. So if it's even subdivisions and u equals subdivs over 2 and v equals subdivs over 2, then we just return new int3. We basically set I to 0. That's the only difference we really make here. And this is just to make sure that we don't have n number of duplicate vertices in the middle. So then we just get the one for the x-axis, I guess. Could you try a concave shape? It's not made for a concave shape. This is purely working in regular polygons, so I can't like deform this one right now. Or do you mean the bevel? Like just applying a bevel? Okay. The bevel on a strange corner. I'd have to find a strange corner to try that. But it should work. There shouldn't be anything about the bevel that doesn't work, so I can just, oh, excuse me. Actually, yeah, if I need to delete these edges in order for the bevel to behave, actually. But I think beveling these two should be fine. Yep. Ignore the weird triangle here. That's unrelated to the bevels, actually. Unironically, it is unrelated to the bevels. Look at that. What a bevel. Okay, so the thing that I want to do here is that I want to add some iteration schemes here. So some enumerable of int3, I suppose. So what do I want to iterate through? I guess it's kind of like just having a function to iterate through all the valid vertices would be useful. So we're going to do that. So now I'm basically going to take this code here and make it a little nicer. That's the goal. So we don't have to do these like for loops every time. So we need v count and u count. And then we're gonna do yield, return, IUV. This is C#. And then we're gonna special case the last one. So if it's even, or no, if it's an even number of subdivisions, which I guess we can just cache. Okay, so if it's an even number of subdivisions, oh wait, we have that here. There we go. Okay, if there's an even number of subdivisions, we need to return the center point as well. That's kind of a hard-coded special case. Why'd you have to remove the other vertices for it to work? Like the duplicate vertices in the center, or because that stuff is purely because I want to have a unique identifier, a unique ID for every single vertex, because I'm going to need to reference them later down the line. And so even if I can like compute the same coordinate regardless of which direction I'm coming from, I need to have consistent IDs for all of these. Salad reloaf time? I did see something moving. It was probably salad, yeah. Okay, so for this, it's basically gonna be 0 and then subdivisions over 2. So that's going to be the center vertex. Cool. Won't that break as soon as you change n subdivs at runtime? Well, that is why I made this one read-only, but in that case n subdivs also has to be read-only. There we go. Actually, that one should also be read-only in that case. Oh no, are you dealing with bad IDs? Okay, so instead of are the IU and IV switched in the inner loop in vertices? What do you mean? Like these? Oh, wait, you mean these two? Yes. Why? I guess that would just change the winding, maybe? Or no, actually, for vertices, it wouldn't make a difference, but it should be like that, yes. I guess it was kind of working by accident, or It was working due to symmetry. Okay, so now we should be able to swap this out with a for each qn dot vertices. And then guess we just do that. I guess I should call it IUV like I did last time. Or you know what? That should just be a parameter. Cool. Okay. This should look exactly the same. Except the center is going to turn red. I think that's what should happen right now. If it turns purple, I'm going to be sad. Okay, cool. Oh yeah, you can see that it swapped the order because it this used to be green and this used to be red. So it's just kind of like swap. Hell yeah. Cool. We should make a similar iteration scheme for the quads, I think. Which means we're gonna yoink this. Gonna just duplicate that. And then we're gonna call it quads or faces. I suppose it's actually kind of useful to call it quads because this one is intentionally not including any of the weird center filling that might be triangles. Yeah, so this is kind of the standard quads. So we're gonna paste that, and then what's the data type here? I guess it would be these, I think. Yeah. I guess it would just be yield return get quad. Okay. So now instead of all of this, we are gonna do for each qn.quads, we got our addresses, and then we just scoop all of that out. And then we get the vertex color from, well, I guess it would be like a00.I or x. And remove those. I guess I don't have IU and IV anymore. Should I name that data type something instead of writing out the whole list of int3s? I don't know. Don't see it. I don't think it's super necessary at the moment. Okay. Does this work? Did we break anything? Or does it still work? Seems to work. Oh, even this case is working. Good job. Good job. Can I set subdivisions to 1? I'm kind of curious if it explodes. Can I pull it all the way down to 1? Or will I get some divisions by 0 or some shenanigans? Alright, 2, 1. Shit! It's not working. Or no, I guess it is working, because like, if it's odd, I don't fill the center anyway. So at 3, there's no center. At 2, I don't fill anything because I don't have to. But at 1, there's only a center. It is just center. Like there's nothing else to it, I guess. So it probably works. It didn't get any like index out of range or anything. So it's just that the hole is the same size as the whole thing. One subdiv center has salad energy, just because it's kind of stupid. Oh yeah, Salad's also. He's also taking a bath. Look at Salad. He's cleaning. Good job, Salad. Good job. Yeah, good job. Good job. Yeah. Good job. Oh. Hey. Good job. Good job, Salad. Good job. When are you handling the donut case? Is there a donut case? What do you mean by that? We're just doing flat 2D shapes. Or do you mean like filling the hole? Okay. Yeah, the hole. I don't know. Like it's gonna be sort of hard coded regardless. So it's whenever I need to, I suppose. Yeah, I guess the question is if I should do the unfolding stuff. Because then I would need to have some kind of n-gon in the middle. Oh, we don't need that. We don't need those. Look how neat this code turned out. Just for like drawing all of this, it's just this little thing. We make a quadish n-gon, iterate through the quads, draw the quads, iterate through the vertices, draw the vertices. And even like this is just a conversion for like all of each like vertex in the quad. So then the question is, do I stop streaming or do I port this to the vertex unfolding stuff to this thing so that this one has support for n-gons? Wait, I added a side count? Oh, I'm just not using it. Okay. Would it work directly for the vertex unfolding stuff? I forget. Kind of depends on how I wrote the code here. I don't think it would be that much work to port this, actually, to be honest. I think probably the biggest thing is that I would have to do something with the center. But it might just work as is, sort of. So what did I call it? I called it a quadrage n-gon. So instead of a quadrangulated triangle, wait, where do I initialize it? Oh, here, okay. You need to shower. Hope you all have a good day. Have a good day, dialog box. You know what? I'll just keep calling it a cutie. There we go. Is even. What is this? Oh, right. That would have to be the subdivision even. Whoa. I deleted too much. Oh my god, stop inserting too many brackets. Well, I mean, I feel like this one should just be public instead of a weird property in the middle of everything. Okay, so this is now going to be a new quadrage n-gon with the side count and n. Okay. So here I iterated through every vertex. So I believe the equivalent code would sort of be what did I call it? IUV in qt.vertices. Yeah, because this is creating each vertex, right? Okay, and then right, we don't have to do conversion there right now. So that would be qt.index to flat coordinate. And then we have a force point. I guess tetra is now IUV. And force point should use the n-gon quadrage n-gon. There we go. Right. Axis locking is not really something we can do with a mask anymore. That's a difference. Wait. In the previous stream, count the edge twice in loop. You forgot to reset edge count on line 157. Which... Wait, in here? Here? Oh, because I'm like... Oh, interesting. Why did it work before then? It would have been trying to make the edges smaller, I think, in that case, rather than like some ideal edge length. in that case, because edge count would have been too big, specifically when calculating the ideal edge length, I think. So it was probably then trying to shrink every single edge the way it worked before, because I left that in. Interesting. So then it's going to behave differently now. Okay. Let's see. IUV. So that thing that we used to call tetra, I guess, is now IUV. And it's an int3. Okay, we used to have a function called isOnBoundary. That is relatively easy. We can just create that function. And the way to tell if an IUV is on the boundary, all we have to do is return IUV.y equals 0 or IUV dot, no, yes. IUV.z equals 0. Right? Yeah, because if it's not on the boundary, none of them are 0. If it's on the boundary, one of them, at the very least, will be 0. Yeah. Cool. Okay, access locking is gonna have to be handled somehow. Got the dictionaries here. So these are gonna be using int3 now instead. And it's not called tetra anymore. It's gonna be IUV. Oh, this is very similar to the way that it worked before. Okay, right. So this is... Okay, so these all need to be int3, and then it's creating faces there. Okay. So this is checking evenness. Is that the center face? I think that's the center face, right? Wait, I'm dragging the wrong sliders. Wait, what? Oh wait, if it's not even, right, okay, yeah, then this is correct. Never mind. Yeah, I guess this would be like getting the center vertices. I guess I can add like a little utility iteration thing for that. Like an IEnumerable. It would just be an int3. Center whole vertices, I guess. So then all we need to do is yield return new int3. Oh, actually, we need to verify that it has a hole first, which means subdivision has to be odd. So if it's even, we throw an exception. Or no, this is more like an index out of range. Center hole only exists on odd subdiv counts found What did we find? And subdivs? Okay. So all we need to do is subdivs divided by 2. Yeah. Subdivs over 2, and then new int 3 ICC. The International Criminal Court. Okay, so now I believe all we need to do is qt.centerHole_vertices, and we do int 3. And yeah, I guess it can still be called tetra if we really want to. Okay, the only thing remaining is the axis lock. So how does this work in the general case? It's like if, yeah, regardless of whether it's odd or even, if IU and IV are equal, then these are axis locked along its own axis. That's one condition. The other one is if the subdivision count is, yeah, if subdivs is even, then vertices where what would that be? It would be where U is subdivs over 2. They should also be axis locked. Yeah. Regarding the previous stream, to solve the wobbliness, you need to have something like C2 continuity. Something like not only checking the neighbor of a vertex, but the next two to get the curve. I feel like I'm kind of getting that, like, I think I'm kind of getting that automatically just from the fact that they, like, the changes propagate, right? Not sure if going from barycentric to 3D works, because flat triangle angle sum to pi, but on a sphere can go higher. I think it doesn't super matter in this case. But certainly if there's like it's sort of making an assumption that your bevel has, you can fit a circle with the same radius in each corner of the bevel. But if it's a really like skew and weird bevel corner, then that's actually not true, because it's going to be a different radius depending on which edge you've selected. So like it's already kind of wobbly and weird as it is. Okay. Axis locking, that's what we were doing. I guess I can have that in this, like in and of itself. Like get, or try get axis lock axis. What's up with the cat in the background? It's my son. He's napping. Ow, ow. Hello. My other son is pawing at my leg. Hey. Hello. It's Mr. Bistro. Hey. Axis lock axis. So here we, yes, Thor is on the ground. UV. How do you make all your points on a semi-sphere? Your previous version looked like those vertices were not on a sphere at all. Are you asking like... Because like previously I was working with a triangle and that gave me barycentric coordinates, and then for the like curved shape I was using a cubic Bezier patch, and then I was mapping the barycentric coordinates to the cubic Bezier patch to get those coordinates. Right, should be a bool. Out floats to axis. Random thumbnail I had for this stream was a cat. Is cat still around? Yeah, I mean, if it was a white cat, it was probably Salad over there. He's around. He's napping. When you did the bevels, it looked like those points were not all aligned on a sphere. When I did the bevels, I'm not sure what you mean by when I did the bevels. Because like I mean, I did have this shape, which this is what I'm using to approximate a sphere, but the construct itself is not a sphere, it's a Bezier patch. So I can just whoop this around to be whatever shape I want. So I'm using it to approximate a sphere, but it's not actually a sphere. Which is good, because the bevels are not always spherical. Okay, so what are the conditions here? If, oh my god, Thor, you are poking at my leg. Why are you poking at my leg? Mister? Yeah, that's my leg. You're poking at my leg. Why are you poking? Mr. Poke. Hey. Hello. Yeah, hello. Ugh. Okay, can I... What? Sorry about that. Oh yeah, I can. Okay, check this out. Check this out. I have the advanced technology now. Look at this, look at this, look at this. Look at that guy right there. You can barely see him. Hey Thor. Hello? That's Thor. I don't know if Thor's gonna show up. Hey, you coming up then, buddy. You coming up? He's just sitting there purring right now. Hey, Misty. Hello? He's just glitching around. Okay. Valid, I suppose. Okay, axis lock. If subdivs are even, then ow, Thor. I guess I don't have to branch here immediately. I guess I can just do if iuv dot y equals Are you out, Thor? That's my leg. You are using claws. Okay, so there's that one. And then... do you think you make modifier like Blender and half edge after 1.0? What do you mean by modifier? Okay. So if wait, I feel like the colors are kind of unexpected here. Or no, it's not. Never mind. If I V I mean, I guess it doesn't super matter to make these locks, because I think when unfolding this, I think it's actually like the forces are probably going to cancel out anyway, but it is kind of nice to have the axis locking as a backup. Okay, so basically if it's even and I V 0, 1, 2, 3. Yeah, okay. Along border, or no, along center of edge. So if it's even and I uv dot z is 0, 1, 2, 3. Yeah. Is n subdivs over 2. Yeah. So if it's along self vertex or it's along the center of edge, then we just return the axis, which I'm going to be lazy. Oh, actually, we need another one. Bool. Or no, that's okay. Never mind. We just do return, no, axis equals flat index to flat chord, IUV, and then we normalize that, which is a little bit wasteful, but that's okay. Life is wasteful sometimes. Return true. Return false. Cool. So now we're not going to use the axis race anymore. Constraint. Right, we're already doing the boundary checking here, so that's good. Oh, we never checked if it's the center vertex. I guess I can make a check for that. Like, is center vertex? Which means this should probably always return false, or no, it should throw if it's an odd subdiv count. Can't get center vertex of odd subdiv n-gon found subdiv count equals n subdivs. Okay. But if it is even, then it is the center vertex if yeah, okay. Return iuv.y equals n subdivs over 2. And z is also subdivs over 2. And then it's the center vertex. Shouldn't that be invalid operation? Isn't that for like operators? Like, oh no, it is more general than that. Exception thrown when a method call is invalid for the object's current state. Oh, yeah. That makes sense. I always thought that was like specifically for like operator overloading stuff. And yes, it should be and. Thank you. Good catch. Okay. So if qt dot is center vertex iuv. Oh yeah, wait, it's just an or here. I wonder when you're gonna cache it and name that n subdivs over 2. I've been thinking about that as well, but I don't think it matters. I think caching is probably not gonna help, and it might actually make it slower. This feels like a case that the compiler is just gonna inline to a local variable. Okay, try get lock access. Okay, I guess we call it tetra here. And then out float to access. Okay. And if that's the case, constraint is then access. But then do we have a lock access here? Or how does that work? Jesus Christ. That's where am I? There, okay. Right. We're just gonna have to lock access. Oh wait, I'll choose to out lock access actually. Okay. And if it's not centered on anything, constraint compute buffer constraint. Constraint is free. Why is it? Oh, it's never used. That's okay, because I will be using it. Constraint force. Get access array. This is now simply lock access, and get access array is no longer used. We can just yeet that into the sun. Am I signing? Yeah, it's assigned. Okay. Wait, why is it still sad? Hides field? Oh, because I'm... Okay, because I'm dumb. Okay, well this is kind of scary, because now it's kind of... It seems like it's just compiling now, but I don't feel like I'm done. How did I do the, like, ideal area stuff? I feel like I'm probably making assumptions here. Let's see, phase count. Oh, that's based off of the mesh. You know what? Let's just see what happens. Let's just press play. If it's gonna break, it's gonna be interesting at the very least. See? Interesting. Cool. This is not the way anything is supposed to work. Oh boy, so how am I doing this? It looks like it's just the order of the triangles, I think, at the very least. So let's go to recalc mesh. Yeah. No, that's not the one. Initialize default. Yeah, here. Okay. So I need to rename these to something useful, like that. So we then need A0, A01, A11, A10, I think. Never renamed recalc mesh? Guess not. This is looking better. I feel like the angle pies are just, I feel like they're kind of unrelated to the whole thing. Like what are these doing? What's happening? Ooh, wait, side count. That's confusing. I guess it's like face side count. But why are my disks incorrect? Excuse me. Internal angles. Angle ideal, sure. Internal angle. That's just a radius. I just feel like it's like slightly off. Oh wait, how do I iterate through them? Oh, I just go through the mesh data. I mean, that makes sense. A vertex 2 point. Are you AI? No, Jesus. What? How did I mess this up? Half inch direction, angle. All of this stuff should be the same. But I wonder if maybe the winding order is reversed, but would that really lead to this? It looks really weird. Well, it's partially... Oh, Jesus. Okay. Oh, we're exploding a little bit. Ow! Ow, Thor! Raise your hands and show on camera? Well, I mean, unlike an AI, I don't respond to prompts like that, so... Ow, Thor! Jesus! Okay, okay, here. See? Close up of Thor. Here he is. He is void. He's way too underexposed right now. But that's the void man. Oh. This guy has been poking at my leg. Exploding because it errors when it can't find the center point? Is that what you really want instead of just always returning false? Yes, because I want to know if I wrote code that was incorrect. And so the fact that I'm getting an exception is thrown means that I have done a mistake somewhere else in my code, which is good to know. Because otherwise it might have silently failed instead of loudly failed, which is way worse than loud failures. Okay, Bim Bim. Okay. Yeah. So you specifically don't want to make even-sided n-gons? No, I'm fine with even-sided n-gons. Do you do any documentation on your code base? A little bit. But not that much. What happens if Thor and Salad touches? Oh, cause like anti-void touch. Usually Thor gets annoyed because Thor isn't a huge fan of Salad. But if Salad is very careful, then sometimes they can actually nap next to each other, which would have been almost impossible like a couple years ago. Hey. Oh yeah, I guess my Photoshop file is kind of like documentation. That's true. Here's my documentation. It's my notes, all of my scribbles for all of my stuff that I've been doing for Havage. But like any other documentation, this might actually be outdated, or it might become outdated because I've changed some of these things, so. Yep. Okay. So let's see. Side count is working well, but when I have an odd subdivision, I'm trying to get the center vertex when there is no center vertex. Cat cam still on? Yeah. Do you want me to turn it off, or? There's still a cat in the cat cam. He's actually kind of void, so, you know, might be hard to see. Mr. Voidman didn't see the cat. Thor is kind of good at being invisible. Hey, little man. Yeah, here's the loafed right where, you know, I kind of want to use the computer and the mouse, but okay, there we go. Hey, hello. He's just sitting here purring. I think he wants food probably. He's probably out of food. I am also very hungry, so as soon as this kind of works, I am going to have some food. Oh yeah, it's probably when I'm checking the axis lock, right? Yeah, because I don't branch this based off of the number of things. So maybe this one shouldn't actually throw. Oh yeah, because this is not get center. This is just, is it a center vertex? Did I have a center vertex thing? I don't. I guess I can make a function like that. Why not? That's been your point. That makes sense. I missed your points. Okay, okay. You know what? This is a property. This is not a method. I still want the case to return false though. Probably, hold on. Like, I'll just do, yeah, like if even subdivisions is false, return false. Probably best to also check IUV.x is 0. Well, that's a case I might want to throw at, because if it's not 0, and you're trying to get that coordinate, that should be invalid. That should just not exist. Like, I could do range checking here too, but I don't know. I'll just leave it like this for now. Okay, Thor. Okay, buddy. Okay. I now have less space for my hands, because there's a, as you can see, there's a little guy currently helping here. Thanks, Mr. Thor. Thanks for helping. You're a little bit in the way, but oh yeah, the angle discs are still wrong. Okay. Not implement an exception. Oh shit, ideal area. It's actually trying to get the area of probably the center one. Can I just exclude this center? Wait, edge count. Is that... Oh no, it's called side counts. Okay. I mean, it's kind of the ideal tri area. What is the ideal area for that? Oh yeah, no, wait. This is just a generalization of... Yeah, hold on. Hold on. We did this yesterday for the triangle. Yesterday? 2 days ago? I don't know how time works. But... where is it? It's in my extremely professional documentation somewhere. I feel like it was here somewhere. Did I remove it? Oh, here. This thing. Yeah, what's the area of an n-gon with side length 1? That's gotta be somewhere on Wikipedia. A regular polygon. Okay. Area. Zoom. Okay. Side S. We know the side length. Side S. NS. Wait, do I need to know the apothem? I shouldn't need to know that. Wait. Oh, area when... Hold on. Oh, yeah, this one. That's the one. Okay. So S in this case is just 1. So it's a quarter n over 4 times the cotangent of pi over n, I suppose. Oh wait, there's like a special case here. The area tends to, okay. I wonder if, yeah, I wonder if Wolfram Alpha can simplify that. Let's check. Wolfram Alpha. It was n over 4 times, or wait, but it doesn't really simplify, right? Because it's just pi over n. And this is probably just telling you what's happening as it's approaching something, so it probably doesn't matter. I don't think it's going to simplify anything. But it's a cotangent of pi over n. Curious if what it says though. Oh, nice. Okay. Okay. Anyway. Let me just make sure. N over 4 cotangent pi over n. Cool. So instead of area tri, I guess this is going to be the weight for the area center n-gon. And instead of square root of 3 over 4, it's going to be this. What? Do I not have a cotangent? Isn't it faster to do with triangle times n? But I can't because the radius is not 1. Right? Why do I not have trig functions here? Or is it just sad because it's, oh yeah, I do have those there, okay. Pi over n, and n is actually not n, it's supposed to be side count. There we go. Okay. You can calculate the area of the triangle with the triangle root function, knowing side and radius. Which triangle read function? Yeah, we don't know radius of this one, so. Because we have the side length, but we don't have the radius. Okay, so this is not the ideal triangle area anymore. This is the ideal center n-gon area. In which case, that's just the every other case. So either it's got 4 sides or it's the center one. Okay. How do we calculate the total area? Because I feel like we might have hard-coded that. Yeah, barycentric dot area is not true anymore. So that's going to be total area. So now we're going to use a different one. What do we know now? Now we know the radius, and n. So that looks like n over 2 times sine of tau over n. Okay. So let's see, it's going to be n over 2 times sine sine tau over n. I believe sine tau over n. Okay. And it was side count over 2. Cool. Okay. Are we using barycentric anywhere here anymore? Oh. radius is set based off of the barycentric edge length. Which is like, I guess I wanna get the, I guess, edge length given this doesn't super matter. I can just do 1 over n or something. Like it can be proportional to that. So, and it should be less than that because I divided it. So I don't know, 0.25. Okay, well, nothing changed. Thor did leave. Yeah, the angle pi's are still super incorrect. Well, it's working for triangles at the very least. It's still weird that this one is coming up as if it's the wrong area, because this should not be red. Why is it red? Solver is at least doing something. Ideal area per face is, oh, it's using, wait, I thought I searched for barycentric to see if I used it anywhere. Somehow I missed this. Okay. Total area. Ideal quad area. Wait, did I get total area down there, or like what's... Oh, I just did area divided by face count, which is not really correct the way that I do this anymore. I mean, I guess I can cache these. Just turn them into fields or something. And then where was it? Barycentric dot area. There it is. Okay. think we have generalized it. Oh yeah, we also wanted to swap the colors. I thought we did that though. I vaguely remember that. Oh, that looks so pretty. Hell yeah, look at this. This looks like this is like a cathedral, but it's not. But it looks really nice. I love this. Look at this. Look at this. Okay, I feel like I need to take a screenshot of this before I accidentally mess it up. The angle pies are still deeply incorrect, but that's okay. So is the church. So my cathedral is also allowed to be deeply incorrect about stuff. Okay, I'm gonna touch some sliders and see what happens. Okay, so this is the default state. Is this what we started out with? Yeah, probably is, yeah. Still weird that it's like fully red. Like this looks like it's telling me that there's way more error than I expect. I'm not convinced I got the code right for the area. Oh wait, it was probably just like not updating. That was it. So it doesn't update the area stuff. Why not though? I feel like it should. Oh, whatever. It should account for the gap, yeah. It's making this so big though. Interesting. Yeah, the weights behave very differently for this shape than it does for the triangle. Huh. Yeah, the center is so big. I thought it was the area weight that made the center big, but increase in the area weighting actually makes it smaller. I would guess it might actually be a probably some assumptions about the angles. I would actually, what happens if I set angle to 0? Yeah, if angle is 0, it looks like it's shrinking freely, right? As soon as I start optimizing for edge length, though, it starts growing again. But I think that probably makes sense, I think. Hmm. Something about this does feel weird though, yeah. Because like now these look so long. They're like super stretched. So I'm guessing that's why it wants to make the center bigger to make these less stretched, right? That would make a lot of sense, I think. Because like now they look so much more relaxed, right? But like this, they're so stretched out. So it kind of makes sense for the center to be big, given the constraints, I suppose. It's also a pretty high subdivision count. What happens if I lower that? Oh. Oh. I guess? I think for such a high number of edges, I think we're kind of approaching territory where like it's so unlikely to even have this many edges in a bevel anyway. So I don't actually think it matters that much. Yeah, there's something about the ratio between like the number of subdivisions per edge and the natural amount to flow into the center has a really weird scaling based off of the side count, where you get this extreme ratio of like repeating patterns. Okay, did we break the triangle or does the triangle work? That would be a good... I feel like it's still showing the incorrect area here. Because like this one should just be perfect. This one should just be gray or like black. Why are my colors wrong? Did I make assumptions about area again? Angles, areas. Correct the maths, the triangle hyperbolics. Really don't need the extra rabbit hole of working it out for n-gons now, though. Neat. That's cool. Why does this fail? So like n equals 4 should not have any color. Oh wait, actually I think the way that I do... Oh, I think I might just have this part wrong. Maybe it was always wrong. Or maybe I accidentally did it correctly before. Or... if these two are the same, it should return 1. Did I mess up the area deviation range? I don't think so. Ideal area per face is the area of an individual face, right? Yeah. But it should be the same for all of them. Except for the center one. Actually, is it different for... No, even versus odd doesn't seem to matter. It's like something is like cached and then... Sometimes it just kind of pops, which is a little bit unexpected. I feel like this should be correct. I mean, I guess I can simplify this code, because this code is a little bit... because I'm doing like multiplicative or whatever. So maybe I can try just using a standard inverse lerp. Just in case I messed up that part, which is entirely possible. Now it looks too colorless. Okay, I guess the slider has to be... Like, this should not be... This should not look like this. What? Why not attach to editor and debug values? I don't know if it's going to help that much. I do think not doing this tonight would probably help. Ideal center n-gon shouldn't be 1. Wait. Here? Yeah, this shouldn't be used. Because there is no n-gon in the middle. Whenever there's an even number of subdivisions. It only applies to quads though, but there's only quads here. Wait. Oh, this is just the default positions, right. Okay, maybe I will just give up for today. I think we made good progress regardless. And then maybe I'll solve it off stream or next stream. Most important part is that we got some pretty looking patterns. Look at that. Zoom. Oh. I can get real spicy. Oh, look at that. It's getting nervous. Zoop. I'm honestly kind of surprised at how much symmetry there is in, like, even when it's failing, there's still symmetry, which I wouldn't expect because I'm not enforcing symmetry. The only thing I'm enforcing is like locking certain vertices along an axis, but I would have expected like tiny floating point differences to matter for the extreme cases, but it really does look like it's failing the exact same way in every sector, which is, I don't know, it's just kind of unexpected. I expected it to not do that. It's kind of neat. Floating point differences happen on all sides at the same time, right? Yeah, but there's no, the values are in world space x and y. I don't do this in local coordinates, so I just expected them to be diverging. Because it kind of feels like it should be, there should be a bias there. What happens when you don't constrain the points along an axis? I guess we can just try it out. Where are constraints? 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 Axis lock. We're just gonna set it to free. Oh, this one didn't change at all. Which is, I guess that is expected, because like there should be full symmetry here. You know what? The area one kind of looks like it's working here. At least in this particular case. It's so neat seeing all of these things propagate. It's also interesting how like the weight for the angular correction does a lot, even when it's very low. And as soon as it goes high, some shapes have crazy instability. Is it just working because the n-gon isn't fighting back? I think the n-gon area correction is right, but I don't think I handled the angles correct, like the angular correction. If I drop the angular correction to 0, it doesn't actually grow it that big. So I think it's the angle correction that's assuming the center is a triangle, or assuming every angle is a quad. I think I have something like that. So I would guess it's just the angular correction. But it's also like, even if it's really big, it's not like, I feel like it's not like that's super incorrect, because that is kind of optimizing making the quads as square as possible. You kind of have to make the center big to do that, because if the center is not big, then you get really stretched quads here. And probably because of the fact that side count is very high. So like with a high side count, like high enough side count and high enough like subdivision count, they're kind of like, it's all kind of garbage. Like, I don't even know how salvageable any of this is. The angles we're trying to be 90 degrees, right? Yes. Yeah, I'm gonna take back the axis lock just in case. How can they achieve it with the gap? Some sounds impossible. Yeah, I mean, it is striving for something impossible. Like, it already couldn't do 90 degrees angles even without the central n-gon. It's just trying to do that, and then we're gonna try to get as close as possible. Yeah, these like high side counts, high subdivision counts are just kind of a nightmare. It just always looks really bad. I like this one. This one is simple, you know? Anyway, okay, I should super get something to eat because I am very, very hungry. Hopefully you wouldn't have 17 edges coming into single vertex very often. Yeah, it's a very weird case. I think the most important part is like you want it to look good with side counts like between 3 to 6. Anything beyond that is kind of like madness anyway. And then n should probably look good even up to high tessellations for these particular side counts. Oh. Oh, it's nervous again. That's super nervous, super anxious. Huh. It's kind of wild that the area optimization is mostly pushing out the center here. I wonder if I made some weird assumptions about the central thing. No, I shouldn't have. Jesus. I kind of feel like as soon as I have like a lot of quads here, I need a lot of iterations because it takes a while for everything to propagate through the many subdivisions. Is the area calculation for individual n-gons the same as the total n-gon? I mean, I'm getting the face area specifically here. But anyway. Why am I pulling that slider? That slider does nothing for iteration. Missed it, Thor? Someone's poking my leg. Oh, don't explode. Nope. Ideal phase area is being calculated based on the center n-gon, right? No, not for all of them, but for the central n-gon it is, yeah. I'm so bad at going to get food. I'm just like stuck, mesmerized, playing with this. Look at that, it's just gooping around. Look at all of these goops. It's like overshooting all of these angles. Roll up. Anyway. Nice sliders are dangerous to productivity? Yes. They are. I'm just sitting here like, ooh, look at it goop. Look at the goopiness. It just goes room. Yeah, the angles are wonky. It might actually be that these issues are related, but I'm thinking it's probably just a rendering issue. I'll probably settle on some default weights. I don't think it's something I want users to control. At least not for Bevels. Because like it would be nice to like cache these calculations too, so you don't have to run them all the time. Because if I expose them to users, you're gonna have to like recalculate them every time, and then I'm gonna have to optimize that code, and there's a bunch of like extra things I have to do there. I mean, I will have stuff like this for UV unfolding. For UV unfolding, I'm gonna literally have weights for what you want to optimize for, but yeah, this is not UV unfolding. It just looks like that. Okay, well, I really gotta go eat. Yeah, the square is also looking incorrect, so something is clearly wrong. Because this should not look like this at all. But I will not do that now because I am getting tired and I'm super hungry and my son is hungry. He is sitting in the kitchen. Hey Thor, hey? What will you eat? Whatever's in the freezer, because I didn't buy food today. All right. Any last questions before I head off? Also, I don't know how to handle notifications for this, because I basically have almost no control over how YouTube does notifications. But it's a little bit annoying that in the YouTube stats, any day that I stream, I lose subscribers instead of gaining subscribers. And I'm guessing it's because people have notifications on, or I'm clogging up their subscription feed and they don't want that. And that might be happening because I'm streaming. Or it's just because I'm reminding people that I exist and they hate me and they're like, oh no, I don't want Freya in my feed. But the more charitable interpretation is that there's too many notifications or something. But I don't think users can filter notifications based on if it's a video or a stream. Because like if you want notifications for my videos, but you don't want notifications for my stream, I don't think there's a way to do that, which I would get if that's annoying. Yeah, it's kind of like it's either too heavy-handed in one direction. In other words, users unsubscribe or disable all notifications, which is super heavy-handed, or I do the heavy-handed thing of making the stream unlisted. But if I make the stream unlisted, basically nobody's gonna find it. So like it's too heavy-handed in both directions. Second channel for streaming. The problem with the second channel is that I need to start from scratch. And like, how do I even find people there? There's probably going to be tons of people who follow my main channel who are just never going to find that channel, even though I might be streaming there, right? And that it also feels like the wrong solution. It's just like, why would I have to make a second channel? It feels really weird. I don't know. Why did you stop Twitch? Because I wanted to try on YouTube to see if that works better. That could be the solution. I mean, so I don't know. My expectation is that it's seeing lives in their subfeeds. Yeah. And like, I don't know what to do about that. So but yeah, like I don't know, like if I make a separate channel, like how am I gonna get my existing audience to even find it, you know? Okay, anyway, well, do you have a Discord link? Well, there's the Discord link for my stuff in general. That's in the, on YouTube somewhere. Like if you go to my YouTube profile, I think there's like links. So I do have a Discord there. There's also the Discord for Half Edge. So if you want to follow the development of Half Edge, if you want to talk to other people who are interested in Half Edge, then you can go there. Link to the website in chat. Is there anything else I want to plug? I also have a Patreon that I don't plug enough. But if you want to support the work that I do, then I do have a Patreon. And I think that's about it. I'm now gonna help my son get some food because he is poking everything he can poke. He's yelling at me because he needs snacks. So I'm gonna get Thor some snacks and also get some snacks for myself. Thank you all so much for joining. And yeah, we hear it. Yeah, he's a lot sometimes. But yeah, thanks for joining. I will see you all next time. No idea when that's gonna be, but whatever. We'll see. Alright. Hey, Thor. Hey. Do you want to say bye to stream? Do you want to say bye to stream? Okay, okay, Thor gets the last word. Where's Hello. It's Thor. Yeah? Or just, it's so dark. Hey? Yeah? Okay. All right. Bye, everybody. See you next time.